welcome to a premier project presentation in this summer 2022 cohort, brought to you by Hamoye. As most of you already know, Hamoye is an edtech startup with a mission to prepare young professionals and college students for their choice careers in data and the future of work. We do that via internship programs which stimulate the conditions you will face while working in a real work environment. Our internships will expose you to specially designed courses, career coaching webinars with industry experts, as well as industry relevant project presentations and collaborations like what we are having right now. My name is Ene Rudolph, and I am a data engineer at Hamoye AI Labs. I'm joining you from Akwa Ibom, Nigeria. I'd like to welcome to this event everyone present, our incredible interns. Kudos to you for making it this far. Thanks to the Hamoye Fellows and the Hamoye team who have made this session possible. Like I mentioned earlier, part of our style is to introduce you to relevant projects, presentation sessions like what we are having today. The idea is to have you collaborate with your fellow teammates and to pick up skills that will be necessary for you as you journey in the field of data science. So for today, we have with us two of our incredible professionals, Basil and Shivam, who will be our judges for this session. We have Basil, who is a data engineer at Hamoye AI Labs, and we have Shivam, who is a data scientist as well as at Hamoye AI Labs. They will be our judges for this session. Without wasting much of your time, I'd like to welcome Christian Alujo, who will be taking over from here and will handle the rest of this project presentation. Hello, Christian.
Hi, Yana. Thank you very much for that. Can everybody hear me clearly? Okay, I guess so. All right, you're very welcome to this Summer 2022 Premier Project presentation. I'm very happy to meet everyone here present, the team, presenters and all. Can't wait to see what you have. Okay, I'll be reading the instructions for this session. As you already know, you have 5 minutes to give your presentation. 5 minutes, no extra time. As you're done, if your time is up, we'll mute you so you can present. Then afterwards, the judges will have questions for you, suggestions, comments, and questions, so you have to answer. So, but it will be strict 5 minutes for your presentation. And we already have our order of presentation. So without wasting any time, the first team to present will be Team Apache. Team Apache. And their presenters, I hope you're here. And also, quickly, before you start, if I call a particular team and you are not set to present, you will be moved on to the last team to present. So I'm going to give you like 30 seconds of grace for you to be available and start sharing your screen. So Team Apache, are they here? Okay. You have 10 seconds less, 10 seconds more to show up, or you'll be moved on to the next. Okay, I guess they're not ready yet. So move on to the next group, Team Collab. Team Collab. Your presenters are Benga and Suleiman. You have 30 seconds. Okay. You're muted. Please unmute.
Okay. Hello. Good day, everyone. Can you hear me?
Yes, can hear you clearly.
Okay.
So, sorry, before you start, like I said, you have 5 minutes. So as you're starting now, your time starts counting down. So just share your screen now and start. Thank you.
I'm not able to share my. Okay.
I've given you privilege.
Can you see my screen now?
Yes, you can.
Okay. So I am. Good day, everyone. My name is Abolu Adegbenga, and my co-partner Umi we are representing Team Collab for today's presentation. Our project title is Crime. Our project title is Crime Against Women in India, a year-wise and state-wise analysis. Year-wise and statewide analysis. So I will dive straight into the presentation. The problem statement. According to official statistics, the number of violent crimes committed against women in India are increasing with each passing year, ranging from sexual harassment to rape and adoption. The likes of Daisy and Khan, among others, have published several works relating to crimes against women in India. These studies, however, focused on India as a whole, but state-level study was practically missing in these projects. This makes this project different from, in the sense that it covers 36 major states and try to understand the relative prevalence of this crime in these states. As for our approach, we first source for the data, perform data cleaning and exploratory data analysis. We moved on to draw insights from visualizations and finally recommended solutions. Data description. The data used for this project was gotten from Cargo and consists of 11 columns and 10,677 rows. The data set contained no null values. The data set was also provided as seen. The statistics from data sets can be seen from the slide. We could not build a model with this data set due to the fact that no label was provided in the data set. Exploratory data analysis. Next, we performed exploratory data analysis. We plotted useful bar, pie, and line charts to gain insights into the data. We performed visualizations for year-wise and state-wide analysis as seen on the slide. Top 3 states with the highest crime rate also visualized. Lastly, we plotted a correlation plot to see the relationship between the different crimes. Okay. Insights from the year-wise exploratory data analysis. We saw that there was a steady and progressive increase in crime rates from 2001 to 2014. Rape, kidnapping, and adoption, as well as cruelty by husband or relative, all peaked at 2014. Also, dowry death peaked at 2011. Insults to modesty of women peaked at 2013, while importation of girls peaked at 2005. We also saw that cruelty by husband or his relative was the most prevalent of all these crimes. From statewide analysis, we saw that Uttar Pradesh, Andhra Pradesh, and West Bengal were the 3 states with the highest number of crime rates from 2001 and 2014 in that order. We went on to do further research on why cruelty by husband was the most popular of these crimes. And we discovered that there has been a long-standing gender inequality present in the country with a gender inequality index of 0.5 as 2014. Also, according to Wikipedia, 38% of Indian men have admitted to physically abusing their wives. We also discovered that the 3 states with the highest number of crimes are highly urbanized states, which would suggest that there could be an intersection between crime rates and urbanization. We saw also from the correlation plot that kidnapping and adoption are highly correlated with rape, suggesting that the possibility that abducted women were raped by their abductees. And our recommendation. Here are few suggestions to checkmate the insistent increase in these crimes. Code of conduct should be strictly implemented across the country. There should be frequent gender sensitization. There should be frequent gender sensitization. Sexual materials should be censored. Efficient and accountable law machinery should be implemented at all levels. We believe that these recommendations will help the country a lot in curbing these crimes and reducing crime against women in the country.
Genga, your time is up. It's just 5 minutes. Okay, I'll be calling the judges now to have any questions or recommendations for you.
Thank you for this, and I hope you guys know the intensity of the problem, that it is very serious problem. And just I have one question, can you show me the data structure, what exactly those data columns contained? Can you go back to the slide? And you talked about the data was not feasible for modeling. So did you thought of any sort of manual labeling possible by any source, any open source tool?
I would like to answer that. In the description of our project, we were not asked to build any machine learning models. We were just asked to analyze the data and gain insights from it.
Okay, that's good. So I just have one question. How would you, as you were having a very good data set, as I saw in one of your PPT, one of your slides, that it does not contain any null values, right? So suppose I am a policymaker. So how would you present this entire analysis to me that I should make such and such changes in my policies that this sort of crime should be reduced in the society? Forget about every statistical and every analysis. What are the outcomes you have got from this entire analysis? Because this is a very serious issue.
You want to know our recommendations, right?
Yeah. Apart from this data, what you were able to draw from this entire analysis?
Okay. Apart from the data provided, we noticed that there was some crimes. There was an increase in some crimes over time, and yet some crimes have reduced over time, like the importation of girls in India has reduced the loss, while the type of crime has also changed. Before, the cases of rape and physical abuse were much, and with time, the type of abuse moved to abuse by the husband or the relatives. You can see that there is a shift in the kind of crime being committed in the country.
Yeah, thank you. That's all from my end.
Okay, thank you, sir.
Okay, thank you very much. We'll be moving on to the next team. That's team deep learning. Are you guys ready?
Yeah, we're ready. Please, can you allow me to share my screen?
Yes, you can.
Not yet.
Okay. You can stop sharing your screen.
Okay. Start my video no later.
Okay, I've already stopped it. Don't worry.
Okay, thank you.
Now you can share your screen.
Hold on, please. 1 minute.
Your time has already started.
I hope you can all see my screen now. Hi,
Yes, you
everyone.
can.
Meji Williams is my name. My colleague Jadisola and I will be standing in for Team Deep Learning, titled Academic Ranking of World Universities Analytics. Here's the list of the other active members. Every year, thousands of people decide to attend university, both at home and abroad. And selecting the best university that meets one specific interest could be a real challenge, since a candidate might not have access to all the facets of the specific university before he or she is admitted. Hence, this project seeks to analyze and determine the most important features that highly contribute to the high ranking of universities, then goes on to develop a machine learning model that can predict the overall score of a university based on the important features aforementioned, all of which will help an aspiring candidate to determine the near perfect university that meets his or her specific interest. Of course, several solutions have been published in view of this. The most well-known of all is the one produced by US News and World Report. But even though several desired factors are put into consideration in these existing solutions, they fail to consider factors such as research focus and intensity, university size, and others. And that is what our own solution improved on by using 4 additional features in training our model. We used 2 different approaches when cleaning the data sets. The first was to drop all incomplete entries in order to analyze the original data sets factually. And this made it reduce to about 485 observations out of about 1,000 each originally. In the second data wrangling approach, some missing records were filled with a guided range of random numbers according to each range and column, all of which are thoroughly explained as contained in the project notebook. And this reduced the dataset to contain about 2,500 out of about 3,000 combined datasets. These datasets contain rankings of about 1,000 world universities for 2018, 2019, and 2020 respectively. This visualization is showing the distribution of the range of overall score. While about 80 universities scored below 30 and only about 5 scored around 95. I will now invite my colleague Jadisola to take us through the further explorations using Tableau visualization. Jadisola, please go ahead.
All right. Hello, everybody. The dashboard that we see here was created with Tableau. So the first one we're seeing shows the size of ranking universities. As you can see, a lot of the ranking universities were large. The second visualization shows the number of universities ranked in each country. We can see that the United States has the most universities that are ranked. Then the third visualization shows the distribution of ranking universities among countries. So basically, the darker the color, the more the universities that are ranked. Then on your bottom right, we can see that, please scroll down. On the bottom right, we can see the research intensity versus classification size, meaning that a lot of large universities, as we can see, had very high research intensity, meaning they were able to publish a lot of research materials. Over to you, Williams. Thank you so much.
All right, thank you. So we went ahead and trained about 7 powerful machine learning models. And when about 4 features were dropped, CatBoost gave the best MAE score of about 6.53. And when we used all the 10 features, CatBoost gave the better MAE score of about 3.658 and R-squared value of about 0.935. So we now evaluated our CatBoost model on our test data set, which gave us 3.46 MAE. This plot is showing the actual values against the predicted values. And this shows that our predicted values are closer to the actual data points. These plots is showing the strength of each of the features in the model. And we can see that academic reputation score had the most contribution, while classification focus had the least contribution. This is the model pipeline. It is showing the flow process contained in the model pipeline. We piped the one-hot encoder and the CatBoost model together to train and to make predictions, of course, with fewer lines of code. And this is a GIF of the deployed model on Heroku used to make predictions. One of the challenges we faced was how to carefully clean the data sets without losing salient points. And this made only data cleaning for the machine learning model to be almost like 300 lines of code. And here are the links related to the project for your perusal. Thank you so much.
Okay, thank you very much for that presentation. Bas, please, do you have any suggestions or questions for them?
Can you hear me?
Yeah, I can hear you clearly. Go ahead, please.
Yeah, sorry, nice presentation. So can you walk me through how you got those? I mean, this is a very nice case study because it probably gets to help students who are trying to probably study abroad or get to make decisions for the choice of university they want to study. So nice case study. But then can you like walk me through or tell me how you were able to get those new features? I think you made mention of getting new features to add to your data set. And why do you think those particular features you got, why do you think they are quite necessary for your case study?
Okay, so in the project, the dataset link on Kaggle, they gave us all these features here, and they gave us the extra 4 features, but those features were not used in the existing solution. That's exactly what I mean. Features like all these classification features like academic, the research focus, intensity, age, and all of that. They were not used in the existing solutions. But by the time we come up with our own model, I mean, in the first testing, we dropped all of those features that were not used in the existing solutions. And we saw that the Catboost model, it gave us like 6.53 MAE, mean absolute error. Of course, we know that the lower the MAE, the better the result. So by the time we now included those 4 features in our machine learning model, it now gave us a better MAE, about 3.46, which means that even the R-squared value too increased closer to 1, which means that the machine learning model is actually predicting well. So that's why we left those 4 features in the machine learning.
So, and then with your feature importance, the feature importance you carried out, those features were like of great importance, right?
Yes, of course, yes, right here.
Yeah. So you said your case study, like it ranges from the year 2018 to 2019. Do you think that's like a good date range or year range for this kind of case study? Why didn't you like get enough data to, I mean, if you try to use this now or put it out there for people to make use of it, you need to factor in like a good number of years to do your case study. So I want to know why you had to do from 2018 to 2019. Why not from years back to present?
All right. So we could not get the data set we could get were from 2018, 2019, 2020. And of course, these are recent years. We are just in 2022. So sure that whatever of course, our model has been trained to predict well. So we're sure that whatever result that our machine learning model gives will still be relevant. Of course, in the exploration, we could also see Massachusetts University and Harvard coming top. And that is the case. I mean, currently, we still see Massachusetts being talked about everywhere, LinkedIn, Twitter, and all of that. So we ensure that our result is actually up to date.
Okay, cool. Yeah, I like the dashboard. Like you guys had to take that direction using Tablet to display some certain information on your dashboard. But then I think it was a little bit too clustered. like a lot of information flying around that I can't really picture out a lot of things. But then it was a very good idea though. So yeah, thanks. That's all from my end.
All right, thank you so much.
Okay, thank you very much for that presentation. That was a nice one. Okay, without wasting much time, Team GitHub, you're next. That is Kizito and Peter. Team GitHub, Kizito and Peter.
Yeah, good day.
All right, you're welcome. You can start now.
You can see my screen, right? Can you see my screen?
Yes, we can. The time has started.
Okay. Good day. I'm Kizito, representing the Team GitHub for the 2022 Premier Project. And our project topic is our employees burning out. These are the list of our active members and our project statements. In this project, we are trying to predict the burn rate of employees in a company, given the various characteristics or the conditions associated with the employee. We also did a segmentation of the employees based on their characteristics, and notice how each of the segments has like features and like burn rates. Okay, the existing problems, the burn rate can be a big cost to the company because they are due to wastage of resources in the company, and there are also existing problems out there. Number one, like offering the work from home options, cultivating the work-lifestyle balance, eliminating arbitrary rules, offering employee assistance programs, and welcoming employee feedback. Our approach to this problem, we did the feature analysis to the invariant, bivariate, and the multivariate analysis. To do some visualization with the analysis we have made. We also did some modeling. We used about 6 models to predict the burn rate of the employees in the company. So the data set was gotten from the Kaggle database, which has about 9 features and 22,750 instances and 1 target. And during the data wrangling, with our missing values, we use the base rule of having 5% tolerance for the missing values, and those columns above 5% tolerance, we have to drop those columns to avoid being biased with our model. And during the data, we did our data explorative analysis and visualization based on the three basic criteria, which are the univariate analysis, the bivariate, and the multivariate. The univariate being the relation, the univariate analysis being the analysis of each of the features, their distribution, and the characteristics. Here you can see the univariate analysis. We have the resource allocation and designation, and you can see they are almost normally distributed. Okay, we also have we did also the bivariate analysis. You can see the relationship. We did the relationship of each of the targets with each of the features with the target, which is the burn rate. You can see how they are linearly. You can see the linear relationship, the positive linear relationship with each of the target with the burn rate. Also, this is also a bivariate analysis. But then our target and the mental fatigue score has a continuous variable. So to help us with better analysis, we have to bind and segment those continuous variables into various bins. These bins were segmented and they were named. Like for instance, for the burn rate, we have the honeymoon phase, the onset of stress, the chronic stress, the burnout stage, and the habitual burnout stage. Now we use this bind continuous features to do bivariate analysis between each of the features. You can see with the color showing the color intensity, the higher the color intensity, which is the darker it gets, the higher the burnout stage, the higher the burnout of the employee. Same also did here. Same thing with what I explained. The color intensity represent the burnout stage and the rest. We also did a multivariate analysis, which is more than 2 features. We did for the mental fatigue score, designation and burnout, which you can see the color intensity also represent the last feature, which is the designation. You can see with the burn rate and mental fatigue score, their relationships are linearly correlated, which is as this one goes up, the other feature also goes up. Then same with the designation, showing the color intensity, they have also a linear relationship with the targets. This is also a multivariate analysis. Also a multivariate analysis where we do more than 2 features, 3 features together, doing that and checking the relationship between them. We also check for the dependencies because, okay, first, let me explain we did for a linear correlation, check for the linear correlation between each of the features. We noticed that the mental fatigue score has the highest correlation with the with the target and the company to have the lowest correlation. But then we also did check for the if there are non-linear relationship, we do the mutual info regression module from on the scikit-learn to check for the non-linear relationship. We also see that the mental fatigue score still has the highest mutual info score, and the company that still has the least. This also acts as our feature importance, which also as our feature importance for the analysis we did. Also, we check for the distribution. We see that our target and some other features are a little bit have a Gaussian distribution. Also, some are having various peaks, which we did with the feature screening standardization to remove those peaks and make them a normal distribution data set. We did our modeling with almost six models, including the linear regression, polynomial. We had to do the polynomial features to grasp both the non-linear relationship between them. Then the best model gave for the neural net model, which we use the SGD, which is static graded descent as our optimizer. We use our a learning rate decay and the momentum. Okay, and also did a relation between the predicted values and our plots. You can see that the
your time is up. Your time is up. Shivam, we have a question for him.
Yeah, sure. Thank you. The PPT was quite good, but just I would like to suggest like to go a bit slower. So in the same regard, can you just go back to the point where you were talking about the missing values, and what are the factors that you kept in mind, like how to select this variable, how to choose this, how to drop this variable? What were the parameters that you thought in mind?
Okay. During the missing values, during the pre-processing, as I told you, we use the benchmark rule of having a missing value tolerance of 5%. But most the feature that we're just having 3 features with missing values. Then we had to at one of them, which is the target variable, and we cannot actually fill with a mean or a mid down for the target variable. So we have to drop all the features in the target variable which are missing. Then for the 2 other columns, they were having more than 5% missing values, and we brought them. Well, we also did our analysis with having these values imputed, and we see that they create a great outlier to our model. Like if it after filling those things with mean or median, if you check our relationship between maybe the mental fatigue score and the burn rate, you see that there's a middle cross-sectional point on it, and those points as such outlier. That's why I had to go through it over again. I had to drop those columns because they actually cause an outlier when we imputed them.
Okay. So which one do you choose? Like, did you choose to drop them completely, or
we chose to drop them completely because they were above the 5% tolerance rate we had.
Okay. So do you think like there could have been any differences in the output of the model if you would not have dropped that variable?
Yes. We actually, as I told you, we actually did a full project with the missing values, and we saw that our root mean square when we had the missing values was actually higher than the root mean square when we actually dropped the missing values. You see that our result and our model gave us a better result and better output as we dropped our missing values. So we actually concluded that those missing values might actually be an outliers if we were to add them.
Okay. So do you have anything in your mind that how you can improve this work? Or were you able to connect this modeling to the real life world? Or there was the outputs were not very realistic? What do you think?
No, the data actually depicted a real life scenario, because from the data you could see that maybe the work from home feature, you can see that those that have the work from home feature available to them, you see that they have a lesser burnout stage or lesser burnout rate than those that don't. Also, the company type, those that work in the service also have a higher burnout rate than those that work in the product. For the resource allocation, those that were allocated more hours to work has a higher burn rate than those that was giving less, that are having less hours of work and resource allocated to them. Also, for the gender, you can see that the males tend to have higher resource allocated to them higher working hours, and also they have higher burn rates. So our data is actually depicting a real life scenario.
Okay, that's good. Yeah, that's all from my end. Good work.
Yeah, thank you.
Okay, thank you very much for that presentation. We're moving on to the next team, Team Jupiter. The presenters are Ayomide and Kazim. Ayomide and Kazim, are they here? I have 30 seconds to define if you're here or not.
We are here. Can you let us share the screen, please?
Yes,
and
you can share your screen.
And please unmute my pattern to Fatai.
You can share your screen now.
It's still not working. Okay. And please, my video, I'm unable to share my video, please.
Then, one of your partner, your presenter, Kazim, can you share? If not, we can move on to the next team you present later.
I'm sharing.
I can see your screen now. Your time has started.
Okay, I don't know. I think my pattern has not been unmuted.
He has, he can unmute.
Okay, Fatai.
Good afternoon, everyone. A few weeks ago, our team was tasked with the responsibility of looking into the HCAP survey, which is meant to answer the big question: is patient satisfaction correlated with overall hospital performance? On behalf of Team Jupiter, Ayomide and I will be giving this presentation on US hospital customer satisfaction 2016 to 2020. Moving on. There is no solution without a problem, and the goal of this project is to provide insights that serve as solutions. Hence, it is ideal that we know what these problems are. First, the survey is designed to produce data that can be used to make meaningful comparisons among hospitals based on the patient's perspectives. Secondly, there's a need for the hospitals to know whatever they might be lacking or looking to improve in their quality of care. Thirdly, there's a need to enhance public accountability in healthcare by increasing transparency. Next slide, please. For the methods used in this project, we started by collecting the data from the Kaggle website, after which we performed our data wrangling and exploratory data analysis. We also performed the feature engineering needed to model our data, after which we tuned and evaluated the best classification model for the trained data set. For accurate use of the data, we had to clean it by checking and fixing missing values, and we also removed the redundant columns. Next slide, we checked through and found some features that were necessary, and those that were not were dropped. Among the features considered, found lots of them to be in the categorical format, and we had to convert it into ordinal numerical values in order for us to perform the data analysis and modeling. Moving on, our analysis showed the best performing hospital to St. David's Medical Care and Rhode Island State with the highest best performing hospitals in US. Ola City also topped the list of the cities with the best performing hospitals. The next bar chart shows the top 5 states with the best performing hospitals. As you can see, Rhode Island is the best performing state with the best performing hospitals. And the next bar chart shows the top 5 cities with the best performing hospitals. Over to you, Ayomide.
Okay, thank you very much, Fatai. So still on our analysis, we also found out something very interesting, and that was the changes in types of hospitals. We saw that there were 3 types of hospital in year 2016, but in year 2020, surprisingly, a new type of hospital emerged. So we suspected that this is one of the strategies put in place by the American healthcare system to confront the pandemic at the time. Here we check the trend in the performance of the individual hospitals. We noticed a sharp rise from 2017 to 2018. And of course, there was this fall in performance towards year 2020. Seeing this was the time of the coronavirus, so we suspect, and of course, lots of industries were affected at the time, so it's quite expected. And to round up our analysis, we checked for the relationship between the patient experience and the hospital overall rating, as this answers the major question in our project. As we can see that there's a positive linear relationship between these 2 variables. So this means that hospitals with an above patient experience national comparison is expected to have an high overall rating too. So here we have the features that were picked for our modeling. And for our modeling, we use 3 models, and that's the logistic regression, k-nearest neighbor, and decision tree. We started by standardizing our data, training the data with our models. Then, of course, and we use the grid search cross-validation to find the best hyperparameter. Then with this, we pick the accuracy for all these models. And from these accuracies, we chose the best model. So decision tree was the best model that was chosen with about 70% accuracy. And finally, here we have the summary of our work. We had bits of challenge as a result of lots of missing values. So that led us to recommending that in the future of gathering data, that missing values should be duly accounted for. And if you are being asked honestly, if this analysis is an impactful one, it's a big yes from us, as we can see how important these insights can be useful to hospital management, to patients, and even investors that wish to invest in the healthcare system. And that will be the end of the presentation. Thank you, judges. Thank you, Amuyi, and thank you, everyone. Thank you.
Thank you very much. That was a quick presentation.
Thank you.
Okay. Bas, you have a question for them or suggestion?
Yeah, first, I think I like this presentation. I like the color consistency and like everything around the slide, how you maintain like the consistency with your color and your fonts and everything. So yeah, cool. Yeah, I love the methodology as well. Everything was clearly stated. So my very question is, with your solution, or if you should go back to your problem statement with what you've done, do you think it was able to answer those questions you outlined?
Yes, it was. It was able to answer the questions, because from the analysis we did, it said a lot about, especially the slide that talked about the patient experience with hospital overall rating. That showed us that patient satisfaction is actually an important indicator of the hospital performance. And of course, the medium of hospital accountability was also answered from our analysis, as everyone around, both people in the healthcare system and people out of the healthcare system, they can actually see what exactly is going on in this particular hospital. They can note their performance. They can note where to improve on and where they need to check. And of course, other people can also see information about, they can get information about these performances and trends to know, okay, this state, this city is doing well with hospital, with the healthcare system and all that. I hope I answered the question.
Yeah, please, from your analysis, what exactly was or were the key performance indicators used in measuring quality of healthcare?
Come again?
From your analysis,
okay,
what is or were the key performance indicators for measuring the quality of healthcare?
Okay, we used, from our features, yes. These features here were the criteria we used in ranking the performance of the hospitals. At first, we would have gone by using just the hospital overall rating, but we later realized that there were a lot of hospitals in America at the time that had 5-star rating. So we needed something more to qualify our ranking. So that was why we added other features like the effectiveness of care in these hospitals, the safety of care, the timeliness of care, and the efficient use of medical imaging, and also the patient experience. So these were the features used to the key indicators that this particular hospitals we are confident enough to say, yes, this hospital is performing well, is doing well in this area of healthcare system.
So the last thing I was expecting to see, or probably I didn't see when you presented that, more like your the data description, I wanted to see like what the features of the data looks like.
Oh, that was due to the time constraint, and we didn't want the presentation to be too bogus. That was why we mentioned, as this feature engineering, like I mentioned, we use it for the analysis too. And also yes, in the data wrangling, we mentioned that we used we found some patterns and we used those and we determined what would be the features for ranking the hospital states and the cities. So basically, we use the same features for modeling also for our analysis because it made a lot of sense. There was a relationship, and we also checked for the correlation using Python. So it just made a lot of sense using them for the analysis, and also conceptually, after talking to a particular medical doctor, we were able to be with confidence, move ahead with these columns of features to do our analysis.
Oh, you guys had to go talk to some medical doctors?
Yeah, I had a medical doctor friend, so I had to talk to him about it and give me some guide about it.
I mean, that's awesome. That's awesome. So, like, if you're given like more time, what do you think you would improve, like in this project? What do you think you should improve?
Okay. To be sincere, even myself and my team, we kept on. We had to force ourselves to be okay with this particular analysis done because we could see lots of insights that await us to be drawn from this particular data. But we have to be time conscious, and we have to make everything come together. So that was why we just brought out the things we felt that, okay, this is very, very necessary. So let us just work on this. But apart from that, if we're given time, we are going to put out more insight from it, and even hopefully try to find the trend from year 2020 to 2022, seeing and try to relate that to, okay, the coronavirus came in 2020, which caused the decrease in performance. And of course, the coronavirus is leaving. So what's now the trend in the performance towards 2022? So there are lots of information that we can actually derive from it if we had enough time.
Yeah, it's awesome. Thanks.
Thank you very much.
Okay, thank you for that. Yeah, we're moving on to the next group, team Keep Flow. As represented as James and Owusu Blessing, team Keep Flow.
I'm unmuted.
Yeah, your time starts now. Yes, we can hear you. Your time starts now.
Okay. Okay.
Hello, can you see my screen?
Yes, we can see your screen. Move on.
Okay, yeah. Traffic accident severity predictions in the UK in 2015 is what Team Kuba Flow will be presenting today. This is my team, and I'm James Okechukwu. Yeah, and with my colleague Owusu Samuel. The problem statement here is that so many traffic accidents are being underreported in the UK, and the ones reported are dependent on the police officers' estimate of the injury, which may not be accurate. And so our aim in this project is, number one, to recognize the key factors leading to this accident severity, and also predict the traffic accident severity on a 3-step scale. Our approach to this 3-step scale are number one, slight. The 3-step scales are slight, serious, and fatal. These are data description gotten from Google. We had okay, yeah, these data descriptions have 32 columns. Yeah, still in it. These are workflow. Data collection, we did exploratory data analysis, we did feature engineering, model deployment, model selection. Yeah, so I continue. Continue, next slide. So our exploratory data analysis, the key findings we discovered here is that most accidents occur in the evenings, basically, particularly around 3 p.m., 4 p.m., and 5 p.m. This is because there might be a lot of traffic at this time, people coming back from work. We also discovered that there's the high number of accidents are also on first class road. We also discovered that in the month July, that's during summertime, that is when accidents are also very high, probably because people are trying to go out to the sun, backs in the sun, and probably have their family members come out for the holiday to enjoy the sun. These are more key findings too. We also discovered that there are daylight in the daytime, more because of the daylightening, and people tend to have some kind of brisk in their eyes, and then while driving, they have a kind of a problem, looking at the sun and also driving. So these are exploratory data analysis. This is the chart here, and we discovered that slight accidents are more, thereby putting our data in an imbalanced state. So there's more of slight accidents than fatal and also serious. So these are the daylightening. We discovered that daylight is also a particular factor that leads to these accidents that leads to the road traffic accident. Probably when the daylight, you could see from our chart here that when the light is very high, we discovered that there's a lot of slight accidents. And yeah, we did our data preparation. Let's continue. These are feature engineering. Feature creation, we did feature creation, we did handling class imbalance because we saw that there's a lot of slight accidents more than fatal and serious. We did our feature selection and scaling. Next slide. Yeah, these are feature selection. We discovered that we selected top 25 features out of all of the 32. Out of the 32 features we had, we selected 25, which gave us a more accurate data. Yes. We did our model training. We used three models to do our training: logistic regression, random forest, and XGBoost. We also did stratified shuffle split. We did on the sampling and oversampling so that our data is well balanced. From the models, we discovered that XGBoost performed very well from the F1 score, that's precision and recall, and also the accuracy. Combining both of them together, we discovered that the F1 score for XGBoost was more accurate. So we decided to go with XGBoost. We selected XGBoost because it gave a higher first positive for the minority classes as compared to other data. And my colleague Summer will take off from the model deployment. Thank you.
Okay, I'm going to demonstrate the prediction here. So we used Streamlit to deploy the app on Heroku, and here's the interface of the app. So for us to make prediction, all we have to do is to go to the to this place and select activity. Here, what I'll do is to predict accident severity. Here, I'm going to enter some information for us to make a prediction. The first information we have to answer here is
I'm sorry, your time is up.
Sure.
Your time is up. Shivam, do you have questions for them?
Yes, I have a few questions for them. Like, first of all, I like the fact that you guys have worked from end to end. You also try to deploy a Streamlit app, and I hope it's working. So just starting from the point that you guys mentioned that the data is only restricted to 2015. Is it true? The data set that was given to you that contains the data only for 2015. Is it correct?
Yes, it was just 2015 data we had. That's just the data set provided for us. Yes.
Okay, so did you try to search from other data sets from the open source platform so that you can make the data set at least for 2-3 more years, or was it not feasible at that time? What do you think?
My colleague, Samuel.
So, like the other question that I have.
Yeah, I get your question. Yes, we decided to. I do not think whether there was room for us to probably expand our data set. We try to stick to what Amoye gave for this particular training. We try to just stick to the 2015 model we had, 2015 data set we had, and from there build a model from it.
So yes. I just got one point from your PPT that during the daytime there is higher possibility of accidents. So, but in general scenario, during the night time there is a more possibility of accidents. How do you justify this?
Okay. My colleague will answer that. Samuel, maybe you unmute my colleague, please. Samuel. Samuel.
Okay,
Hello, can you hear me?
worries.
Yes, he wants to answer that.
Okay.
Based on the data that we have more cases of accidents in the evening, and while from the analysis we also did, we noticed that accidents are most likely to be severe when they happen in the midnight. And also we also did some other analysis that accident is much less likely to be severe if it happens near traffic signal. That's what from the analysis that what we noticed.
Okay. So just a last question, like, can you explain me your performance metrics, PPT,
Okay.
like this slide?
Okay.
And how did you selected the test model, or you just gave the results parallelly?
No, what we did to select the features, we use our motion information scores to estimate the importance of the model. Then from there, we're able to select the top 25 features. I try using 10, 15, but 25 features give us the best performance. And F1 score was used to estimate the performance of the model. And we have an F1 score of about 78%. Due to time constraints, we're not able to like use more models or do some parameter tuning. Well,
that's what I was like thinking, like there can be more number of models and you can have some more hyperparameter tuning. So do you have any plans, like if you have given at least 1 week extra, so what could you improve in this entire project? And what would be your end results? Yeah.
Okay. Based on this is a very good project, but what we tend to do is to like get more data sets, especially getting more cases of accidents when we have serious and fatal accidents to handle the class imbalance. Then from there we can have more information given to our model. Another thing we can do is to like use different models, do some tuning, and with that believe that our model will perform very good.
Yeah. Thank you. Like it was a very good work. Yeah.
Thank you very much.
Okay, thank you very much for that presentation. And the next team to present will be team Kubernetes. And we'll have Saskija and Okeke Tobena.
Ogo. I'm a second before. There was on the cinema. That's why I give you.
Hello.
Yeah, I can hear you.
Okay, can you unmute my?
He's already unmuted.
He's going to share his screen. Okay, good afternoon, everybody.
The time has started.
Okay. Our topic we were given to them was divorce prediction, uncover what makes relationships last or break. Uncover what makes. This is our project members, and our problem statement was next. Okay. We noticed that there's a lot of.
Sorry, can you please speak up, please?
Can you hear me?
Yeah.
Okay, we noticed that there's a lot of divorce that have been happening recently, and especially in our country, Nigeria. So let's just go. A number of these times, the unwillingness in relationships to lead to divorce gets ugly. So we decided to make a model that would help a marriage counselor predict the probability of a relationship ending in divorce, or the top questions that were the main causes of divorce. Next slide. Our objective was to build a machine learning model with the Streamlit app and investigate what could make a relationship last or break. Next slide. We had some duplicate values, no missing values. So we used pandas to remove duplicate values. Our machine learning algorithm had an accuracy of 95.6%, and we did some ED analysis. Next slide. Okay. Our data description. We noticed that there were more married people than divorced people, ratio of 0.56 to 44. That is the distribution of divorced people throughout the entire data set. Next slide. During our EDA, we we got our top 10 correlated questions. We noticed that questions 40, 18, 17, 19, 11, 20 were the highest questions that correlated to a relationship ending in divorce. Next slide. Next slide. Okay, and these were observations from the whole analysis. We noticed that in general, the more positive the answers were to these questions, the more chances that the couple was divorced. We also noticed that questions 8 to question 30, we noticed that a lot of divorced people agreed with these questions, which was unlikely, showing that they may have been negative questions because from data set given to us in Kaggle, we also found some issues with some people that had the same problem. We also noticed that both married and divorced people agree with questions 6 and 7, though everybody that agreed with questions 7 ended up divorced. That is, we feel like strangers at home. Next question. Next slide.
Okay, so this is where I'll come in for our model training and evaluation. So we did our feature selection with the lasso regularization, and then we used the 10 features whose weights were now reduced to 0. And then we used an district regression model, and we had an accuracy of 95.6. We had a false negative, we had no false negative, and we had 2 false positives from it. And we deployed the model with the Streamlit app. And this is just a demo of it. These are the questions, and our model was able to predict divorce risks with the probability score. So I'll hand on to Sabina for a conclusion.
So in conclusion, basically what we found out was that these questions, divorced people agreed with the questions. Most of the questions, apart from these questions 10 to 30, there were a lot of discrepancies there. Divorced people agreed with questions like they enjoy going out with their wife, which we all know is wrong. So we deduced from data set that those questions 8 to 30 would have been negative questions. That is, a positive answer meant a negative feeling. That's the summary.
If time permits, I can just like to share these are app, and if you want to make a live prediction, we can just go to the ML, and you can answer questions based on this, and then you can just, when we need it, we can take out this question with my part from the beginning.
Sorry, your time is up. Basi, do you have questions for them?
You can hear me?
Yes.
Yes, yes, we can hear you.
So, so you're basically predicting like divorce, the likelihood of divorce happening, right?
Yes.
All right. So, and the person that can use this this solution, or the person that can use this is basically
a marriage counselor.
Okay, marriage counselor.
Yes.
So, okay, my question is, are those Q43 are those questions? Are they like structured questions?
Yes, yes. Let me share my screen to show you the question.
So those questions, like, do they apply to every marriage? Like, I mean, so many marriages have different issues coming to a counselor, like their problems or whatever like the issue they're having could vary. Does that question, is it kind of specific or generic?
No, it applies to every marriage. Could I share my screen?
All right, we don't
Okay,
have
can you
time.
see the questions?
Okay.
Yes.
So these
These are
questions, they are more generic.
Yes.
Okay. Now another question is, so some people can get divorced after a year of getting married, and then some people can as well get divorced after 20 or 30 years of marriage. I mean, yeah, it's possible. But then my question is, like your solution, how does it factor in like people that have been in marriage for years, for a couple of years, or people that have been in marriage for like within like a year or two?
The questions are structured in such a way that the time frame doesn't really play a part. Like, for instance, take question 7. We are like two strangers who share the same environment at home rather than family. If a person was married for a year or 30 years, it doesn't matter if they have this feeling of each other. We found out that everyone that answered positively to this question was divorced. There were other questions there we found that are inside our notebook slide.
Okay, so I'm seeing a question there. I enjoy traveling with my wife. I mean, some might be married for a year and they've not traveled. So if that question is like if it gets to be void, or they choose not to answer because they've not experienced, traveling together, does that affect the quality of the model prediction?
No, it doesn't, because we try to not put this in our model based on our feature selections. We put questions that will be holistic to everybody.
All right. Yeah, that's all. That's all from my end. Thank you.
Okay, thank you very much for that presentation. Next up, it will be Group Matplotlib. Group Matplotlib, that's David Oyedekun and Umadabo.
Yeah, we are here.
Okay.
Yeah, we're here.
Can start sharing. Your time starts now.
Okay, share your screen. Okay. Okay. Okay, good afternoon. My name is Abdulhafiz Umar Dabu, and together with my colleague David Odekun would be presenting for the Matplotlib group. And our project is global population estimates. So understanding the distribution of a population and also the demographic information allows for proper allocation of resources to that particular population or nation. And our objective is to analyze Africa's population trend in terms of the total population, to visualize Africa's population trend in terms of gender, to also develop a model that gives estimate of the population of a country in the near future. So the approach we use is we use Python data science libraries, including Python, including pandas, matplotlib, and scikit-learn to analyze and visualize the data. We also use linear regression to develop a machine learning model that can predict the population of a country in the future using the population of the past. So the data set we used for the purpose of this project, we obtained it from Cargo, which was generously made available by the World Bank, and it contains 95 columns. Also, the data contains some missing values. That means the data was not clean, which we had to perform some data cleaning. Also, the scope of our project would be to to investigate what the population trend of Africa look like. Also, what the population trend of male and female lower dependents ages of 0 to 14 of Africa's most populated nation. So we performed exploratory data analysis, and the chart on the screen describes how the population of African countries evolved from 1960 to date. Also, and it has shown that Nigeria, which is Africa's most populous country, has maintained an increase in population and is expected to keep this up to 2050. Also, Ethiopia and Democratic Republic of Congo has also experienced significant increase in population. This visual shows what the population trend of male and female lower dependencies of Africa most populated nation look like, that is Nigeria. And it shows that the female dependence in Nigeria has increased from about 10 million in 1960 to over 40 million in 2022. And the current population of Nigeria amounts to about 220 million, which means this population represents about 1/4 of Nigeria's population. Also, the male dependent population of Nigeria has also experienced a steady growth since 1960, even though when compared with the population of female dependencies, it is not the same. Okay, I will now hand over to my colleague, Mr. David, to proceed with the model training.
Okay, yeah. Okay, good day, everyone. I'll be talking about the model. We used a simple linear regression for the creation of our model. I don't know. Okay, I want to share my screen and come. Okay, so yes, I want to share my screen. All right.
Yes, you might. You can go ahead, please.
Yeah, okay. I don't know if you can see it right now. Can you see my screen?
You have 10 seconds more.
Oh, wow. So we use a simple linear regression model, taking into consideration the previous population over the years, starting from 1960 to date, and we're able to create a model. We're able to create a model to predict population. I don't know if you can see my screen right now. So, for example, now let us predict the population of Togo.
Time up. I'm sorry, there's no time for that questions. Shivam, you have questions for them, suggestions?
Yeah. The first thing, like the graph that you showed, that was not visible because I think it was shared by mobile or something. So first, just a advice, like whenever you are presenting, you should always try to present via a laptop or a PC. And you talked about that your data set was having 95 columns, right? So when we think of about any machine learning algorithm, it is nothing but a mathematical equation, right? Suppose I'm talking about y is equal to mx plus c. The moment I'm trying to increase the variables, the more complex the equation will be and the more complex the situation will be. So I'm just curious to know, like, how did you manage to control the variables? And also you did not talk about any sort of model validation. I'm just curious to know that things. Am I audible?
Yes, you're audible. You're very audible. If they can't answer the question, we'll have to move on to the next team. Okay. All right, that'll be for team Matplotlib.
Okay.
Moving on to the next. Your time has already gone. You took too long to reply. Sorry about that. Moving on to the next group, team Multicollinearity. Representatives are Triumph and Aisha. Triumph and Aisha, are you here?
Yes, we are here. Hi, everyone.
Okay.
Let me share my screen. I hope my screen is visible. Okay,
Yes, you
so
can see it.
yeah, hi, everyone. For today, we have this topic, UFA Leagues Analytics and Predictions of Team Qualification to the UFA Champions League. This is our team members. Aisha and Triumph will be the presenter of today. And so first, let me describe about UFA. UEFA stands for Union of European Football Association. UEFA consists of the National Football Association of Europe and runs national competitions such as UEFA Champions League. So our problem statement in this is to identify the teams from different leagues which qualify for UEFA Champions League. These are the 5 steps for our projects. For data sourcing, our data is from Kaggle website, which hosts data sets and allow users to build models and do analysis on it. In data cleaning, we renamed our unknown columns and checked for any null values in data. We didn't have any missing values or duplicate rows in our data set, and our data set contained 24 features and 684 records. For EDA, we created a few functions to remove repetitions of code. We then checked for correlations and patterns between features. For feature engineering, we created a column as our target and assigned numerical values in it. At last, we tried different algorithms and selected models which provided higher accuracy. Then this is EDA part. There's a visual representation of a distribution of points across 6 UEFA leagues from 2014 to 2019. Our dataset contains information from year 2014 to 2019 for 6 different leagues. Here we can see that in these 3 leagues, that is Series A, La Liga, and EPL, we had almost same number of points. While we can see that for RFPL, we have less number of points, that is almost 12%. Here's a number of teams in various leagues. Every league had different number of teams in our data set. For Series A, La Liga, and EPL had 30 teams, while League 1, 29, RFPL 25, and Bundesliga 24. This is the average point won per team in the league to identify which league have more competition. According to our analysis, RFPL is a more competitive one. So this is the function we created to find the average number of points by each team in particular leagues. Here we created different data sets for each league and called the function to find average points. Here's a screenshot for 2 of the leagues as samples. There's another function we created to plot total number of points by top 10 teams in particular leagues. As a sample, we can see the bar graph for RFPL and Bundesliga league. We can see that over years, Zenit and Petersburg. One second, I guess. Yeah, this is the top 10. I'm sorry. Yeah. Okay, this is the top 10 leagues. And here, okay, this is another function we created, which predicts the number of winners. So here we can see that this team, St. Petersburg, won 3 times, while the other teams won once over the years. And here in this particular league, this particular team won all the 6 matches over different period of years. There's a heat map we created and which helped in describing how our features are correlated. This is feature engineering. We created an extra column in our data set where we decided which all teams qualify to participate in Champions League. How we did that is that there is a different criteria for each league. For some leagues, team having position 1 only qualifies, while for some other leagues, the top 3 team qualifies. So after reading rules of different leagues, we created this code to decide which all teams will qualify for Champions League. This is the machine learning part. This will be presented by my co-presenter, Triumph.
Thank you, Aisha, for your presentation. To start our model, we initialized the baseline accuracy that we needed to beat, and we used that by assuming a naive model makes a single prediction throughout what's the maximum accuracy that I could get. We found out that accuracy was 0.83, and that was what we needed to beat. So next slide, Aisha. We started with a linear regression model where we used one hot encoder in our pipeline. Sorry, logistic regression, forgive me. We used a one hot encoder because we included the league, which is a categorical data. And we got an accuracy of 0.94 and a testing accuracy of 0.96. And you can see we printed a confusion matrix to analyze deeply what our model was doing. Next slide, please. We decided to use a decision tree classifier so that we can incorporate more of our features. And we also use one hot encoder in this. We got a training accuracy of 1.0 and evaluation accuracy of 0.92. We found out that this meant that we had overfitting in our training sets. So we decided to do some hyperparameter tuning to be able to adjust the maximum depth of our tree. Next slide, Aisha. So after adjusting, we chose a maximum depth that we use and use that to retrain our model and got better results. In conclusion, we found the odds ratio of our features and found out that being, I'm 2 slides ahead. 2 slides ahead. Yeah, so we found out that being in the Bundesliga gives you like more than 4.
Sorry, time's up, time's up. Shivam, have a question for them? Or Basi?
Yeah, please, can you go ahead and like that conclusion? I need to hear the conclusion, please.
Okay, thank you. Looking at our odds ratio, we found out that being in the Bundesliga gives you about 4 times greater chance of qualifying for the EPL, for the Champions League. This could be explained because Bundesliga had fewer teams and the size of the number of teams by UEFA that qualify for the Champions League are 4. So that gives a chance. Looking specifically at the gameplay, you can see the 4th item on our odds ratio is the non-penalty expected goals. This is this increases when a team is a higher pressing team. So a higher pressing team has higher non-penalty expected goals, and this shows us that when that increases, you have higher chances of qualifying for the Champions League. And then on the bottom, we can see the RFPL. As Aisha earlier told us, the RFPL was found to be a tougher league. And from UEFA rules, only the team that comes first qualifies. So this shows us that it is more difficult to qualify from the RFPL. I'll stop here. Thank you very much.
All right, yeah, so what guarantees in each of these leagues that do qualify for the Champions League, what guarantees a team a slot in qualifying for the Champions League?
Okay, thank you very much. Aisha, if you check the features engineering slide to help to throw more light on that. Yeah, that one. Yes, so the first thing we did was to create league codes. Since the leagues are categorical data, we use this function to create league codes. So each league has different rules. So the 4th league, which is the first line of that, yeah. So RFPL, only the team that comes first qualifies. In the League 1, the team that comes first and second qualify. And then in the others, the teams that come from 1st position to 4th position qualify. We found out this from UEFA's guide rules online.
Okay, and with your solution, were you able to I mean, from your problem definition, you said you need to find like expected goals and other metrics. So with your solution, are you able to be able to predict expected goals? Like, are you predicting the expected goals, or there is an expected goals for teams that are going to qualify for UEFA?
Okay,
I don't think
good
that was
question.
clearly stated. Yeah.
Yes. Okay. Now, first of all, we created a new column that tells if a team qualified or didn't qualify. That's what happened here. Now, Aisha, if you scroll down to the odds ratio, conclusion. Yes, so we are trying to see what affects a team's qualification or not qualification, not qualifying for the league, for the Champions League. You can see when your non-penalty expected goals increases, your chances of qualification increase. After that, we see that when your expected goals against difference, in other words, this metric measures the expected goals your opposing team is expected to score. The more you increase the difference, in other words, the more you prevent your opposing team from scoring, the better chances of qualifying. And then after that, goals scored, the more goals you score, the better your chances. Opposing OPPDA coefficient stands for opposing passes per defensive action coefficient. It basically measures the your high pressing, the power of your pressing. How high does the team press, or how low do they press? If you're opposing, this one measures for your opposing team. Now, a team that has low pressing has a higher PPGA. So this shows us that if your opposing team presses less, in other words, if they play deep football, then your chances of qualification is better. I don't know if that answers your question.
All right, thanks.
Thank you.
Okay, thank you very much for the explanation. We're moving on to the next group NumPy. Our representatives are Orina, Sakinat, and Saliokyu. If I made that name correctly. Team NumPy, Orina, Sakinat.
Yeah.
Okay.
Okay, I'll share my screen now. Can you see?
Yeah, we can see. Your time starts now.
Okay. Good day, everyone. My name is Sakinat. I'm also here with Tolu, who will be representing Team NumPy. The topic of discussion is Premier League match prediction. We'll be following this agenda from introduction to conclusion and recommendation. Information about our team can be found on this slide. Football, the outcome of a football match is very unpredictable. Stakeholders like managers, even team coaches often like to be able to predict their match. Therefore, they look for information that can help them maximize their winning chances by focusing on their opponent's weaknesses. This project has two main objectives, which is to identify the key features from historical data gathered from years, and also to use those features to build a machine learning model to predict the match outcome. To address that, we collected our data from Cargo on Premier League match from a period of 2014 to 2020. We had 2,660 rows and 40 columns. The overall workflow can be summarized in this diagram here. After our data was collected, we did some data exploration and visualization into the data preprocessing stage to the feature engineering. Then we reduced our feature sets to the significant features. The final data set was then used to train our model, which was the random forest classifier, which was later evaluated and deployed. During our exploratory data analysis, we found out that 31 teams participated in the Premier League match. As you can see on this, the home and away team that had the highest win was the Man City, followed by Liverpool. I'll hand over to Tolu here. He's going to continue with
Thank you very much. Thank you very much, Sakina. Moving on to feature engineering. We actually, after looking at the data properly and discovering that we had 40 columns, we decided to actually see how we could reduce the feature matrix. And what we were able to come up with was that some columns were not actually important. And also for the dependent variables, we label and encoded the dependent variables so that our model can run the proper prediction. And we also had to label and encode the two particular features, the home team and the away team, as we had 31 different categories in those particular categorical variables. Moving on to model training, we fitted our data to the random forest classifier, and we were able to obtain this feature matrix, this feature importance that we can see here. And of note is the away team rating and the home team rating, which proved to be very important for determining the result of the match. Afterwards, we evaluated our model and we discovered that our model actually did very well for 2 of the classes out of 3, away win and home win, while for the draw, we didn't do well. And this can allude to the fact that we had lower number of examples in the draw, in the data set. Yeah, this is our prediction matrix, the confusion matrix, and it explains to us the performance of the model and how well the model can predict for a particular class. Let's go on. So we went further to deploy our model, and with the goal in mind, that is to predict
for a given match, which team is going to win in that match, or is it going to draw, or are they going to lose? Something like that, like an away win. This is how we did it. So, Sekina, please show us the demo.
So values to make this very short, so I don't be taking prediction pattern of the submit pattern.
You have less than 30 seconds.
Yeah. So after clicking this, we can see that we were able to make a prediction, and in that particular prediction, Arsenal won Tottenham for the given features. In summary, we can say that we would need more stakeholders' input, and we actually need more data. That's our recommendations, and it is something we can ship to people that actually need this. For example, teams anywhere the teams are. So far, we have the data. We are able to make proper recommendations and predictions. Thank you very much.
Thank you.
Okay, thank you for that presentation. Shivam, you have suggestions, comments?
Yeah. So in this entire problem statement, you talked about like whether the team is going to win, lose, or it is going to be a draw, right?
Please, can you come again?
In this entire presentation,
yes,
your end goal was to find out like whether the team is going to win, or it will be a draw, or they are going to lose, right?
Yes, of course.
So I just have in your entire PPT, you mentioned about like there was the data regarding the draw was too less. So how did you manage that imbalance problem?
Okay, so that was why we had the prediction matrix, so that we will be able to understand which problem we had with the data, and also to manage that, we would normally use we could, depending on the goal, which was to predict actually whether we are going to win or we're going to draw, we could use an imbalance classifier like imblend, for example, but we didn't really have time to go into that. So we just took the random forest classifier and went ahead.
At the same time, you only worked upon one model, right? But what I would suggest for future is like, whenever you are working on any such problem, you should try to work along and try along different models and then see which of them is performing better, and then try to choose and come up with the best model.
Okay.
Right. Yeah. And at the same time, and you can also always try to look for any open source work that has already been done. You can always incorporate in your work.
Okay. We will do that.
And do you have anything in your mind, like if suppose given a chance, how would you improve your work?
Okay, to improve this now, instead of having to enter the values by hand, you could just check for a given opponent. You can check for the either you are predicting whether that team is going to have a best performance. That was like an improvement that we didn't also have time to do. Whether that team has a best performance. So instead of hard coding them, the model will just generate it, or there will be a logic in the program, in the Flask program.
Okay.
That was.
Yeah. Good work. Yeah. Thank you.
Okay, thank you very much for that presentation. Moving on to the next group, Team Pandas. Your representative are Adewale and Emmanuel Ashinze. You have the floor now.
Yeah. Hello.
Yeah, we can hear you clearly.
Can you hear me now?
Yes.
Okay, I'll share my screen now.
Time starts now.
Okay, just to confirm, please, can you all hear me?
Yes, we can hear you and see your screen.
Okay. Good evening, everyone.
Ashins Emmanuel representing Team Pandas, presenting our project on stock trades. On stock trade, based on the data sent to us by Moyi. So these are the team members. Let's go on. So stock trading is not just what backs the financial markets every day, but it's one of the things that ensure every single company and every product that we use every day keep going on and on. And in the last 2-3 years, there's been a boom in enlightenment when it comes to the stocks market. Everyone is all about Apple, Tesla, who I should have gotten this stock, or I should have gotten this before it's probably rose. So having an idea of what could happen the next day in the stock market is more like a superpower. So we're giving a data set, and the problem statement is to do a data analysis on the data sets to be able to draw patterns, and after drawing the patterns, using those patterns and some of the features we deem important to predict what could happen in the next day's stock market. So how did we get our data? The data set was obtained by Kaggle, and it focuses on the historical stock prices of tech companies ranging from 2010 to 2017. It comprises of 851,264 rows and 7 columns. And then you have the opening, closing of the stock prices, the low, high, and high prices, and the volume. All the features were used for the prediction, and the data set is clean and accurate for our prediction. So the steps we use in our prediction for this particular project, we got the data from the data source, we cleaned the data and did some feature engineering. Then we did some model building and selecting the best algorithm for our project. And we evaluated the project and we deployed it to a website for an end user. So before I get to the nitty-gritty of the model and the model description, I'll hand over to my partner to go over the exploratory data analysis. Mr. Desokan, please.
Yeah, thank you very much. So good everybody. My name is Aisha Koslamon Adewale. For the exploratory data analysis, what we did was that we used the trading volume to select 3 companies so that we can do our comparative studies. So in the information and technology sector, and the 3 companies are Amazon, Microsoft, and Apple. So after that, we did the EDA based on the price action. We used the Bollinger Band and the KDE to measure the volatility of the 3 companies. We did some financial analysis so as to know the daily return and the cumulative return of each company. From what you can see on your screen, that is a Bollinger Band for Amazon. And basically, a Bollinger Band is just moving average plotted inside 2 bands, upper band and lower band, which are two standard deviation away from the moving average. So we can see that we have an upward trend in the price over the years for Amazon. And the tightness in the band indicates a kind of drop in volatility. That shows Amazon is a stable market compared to the other 2 companies. Move the slides, bro. So this is the Bollinger Band for Apple, like the other one that was shown before. So we also have an upward trend of price over the years. And this is not as thick as the first one. That shows this Apple asset is more volatile than that of Amazon. So continue. Same thing goes with the Microsoft band. So an upward trend or upward movement in the price over the years. So continue with the.
Okay, so that was a nice one with the model, with the exploratory data analysis. More insights can be drawn from the notebook, which links will be shared shortly after the presentation. And then for the feature engineering, we made sure the data set, everything was properly shaped, and we used the min-max scaler for optimal performance and to deal with some particular layers in building the model. So for the model building and selection, we're selecting a particular model, looking at the data type. The time series data type is not necessarily the one that has to do with a form of classifier problem. We are trying to find the relation between each point of the data set. We are trying to find the relationship between different sets of data points.
You have 10 seconds more.
We tried different algorithms and we selected the LSTM. LSTM had the best performance, and we hosted this on this particular website, which I will express. So the results of the predictions, as you can see, the validation and the predictions are quite close to each other. The model has an RMSE of 29.78, which shows that we could be confident in our prediction. So in summary, having an idea of what could happen in the next day in the stock market is more of a superpower and very important. And this is not just for it's for anybody that is to get into the stock market, investors and analysts and everyone that can try to forecast ahead of what they can do.
Time's up, sorry. Okay, Bas, you have a question for them, suggestions, comments?
Yeah, so which stock exchange, like from the project, like where it was listed, they said like your case study or is basically like the New York Stock Exchange. Was that what you used for your analysis?
Yes.
You use the New York Stock Exchange?
Yes.
Okay, sorry. So the quick one. So I mean, stock exchange, I mean, is basically the sales and purchase of security shares and other stocks and bonds. So we all with what you've done, like, could it help me to predict what like, you know, give me a recommendation of the best stocks and shares to purchase?
Yes, based on what we've done, although we were unable to capture everything in our slides, so based on the analysis we did, I mean, the volatility and the stability and the return and the cumulative return, the financial analysis, so we'll be able to suggest the kind of stock that is stable and the one that has a higher daily return and higher cumulative return over the years.
Okay. And your case study, like the data set used, that was from 2014, right?
No, it was from 2010 to 2017.
Okay. So what exactly were the features of your data sets like?
The dates, we have the OHLC, the open, high, low, and close, and the trading volume. So, but from our analysis, we were able to generate some more columns to the data set, like the market cap and the daily return, the cumulative return, the moving averages, and the others.
Okay, I mean, these are very important projects, honestly, and I feel like you should have taken a very more detailed approach, you know, to this, solving the problem. So probably maybe because of time constraints and all, you didn't do that. But I mean, it's a very important project. Like you can use it to predict stock and get information about how to, you know, purchase stock and shares and all the rest of them. So
yes, of course.
All right. So I mean, you can still go back to it to improve it, honestly. All right. Over to you, Kristen.
Okay, thank you very much, Basi, for that comment. Okay, without wasting time, moving on to the next group, Team PySpark. As their representatives are okay, Motosho and Jane.
I cannot share my screen yet, please.
You can now.
Good day, everyone. Good day, everyone. I'm Jane representing PySpark, and I'll be presenting with Temitope. Our project presentation is based on online job posting data sets, and our model aims to assist job seekers in quickly digesting online job descriptions, get keywords, and incorporate them into their application. These are the team members of Team PySpark. Next slide, please. These are the team members of since PySpark, and the job market is buzzing and filled with both qualified and unqualified applicants who cannot communicate their talent.
Cool.
Recruiters utilize job boards like the Armenian Human Resource Career Center to advertise opportunities, and then use applicant tracking system known as ATS to sort through each application. Basically, this is how ATS works. Once a job is open, potential job seekers see them on various platforms. Job seekers show interest, recruiters rank their qualification, job seekers go through an interview, and then the top candidate is picked. So what's the problem with this? Most candidates are rejected with this system because their resumes lack the relevant keywords. The existing solution, which is the ATS system, filters candidates who appear to be a suitable fit. But how can job seekers match their credentials to the posted job description? Most candidates are rejected because their resumes lack the relevant keywords. However, this is also a tedious practice. What is our solution? Our approach utilizes machine learning models built using natural language processing to understand the human language and to predict if a job posting is IT related or not. Our data set was obtained from Kaggle, consisting of job posts from 2004 to 2015. Our data set had 19,001 rows and 24 columns. Every column's data type was an object. However, the year and month column were in integers and the IT column was Boolean. The data cleaning and preprocessing was very tedious. There were a lot of non-values. We had to change the data types of our columns, remove a couple of columns with about 70% of their content missing, replace text, make text lowercase, and utilize natural language processing models for our data set. Our visualization. This visualization shows the total number of jobs per year, with 2012 having the highest number of job posts across IT and non-IT industries, and 2004 having the lowest. Other visualization you can see, next slide. And then our final visualization that you're looking at here, on the right, we used word cloud to visualize the 50 most demanded jobs with the most mentioned in bigger and bolder sizes, as you can see. So I'll hand over to my fellow presenter to continue.
All right, so for this project, we use two different models, which are the word cloud and the random forest classifier algorithm. Word cloud is a library built using natural language processing. It was used to group the top words in the job descriptions from job postings to help applicants predict if a job posting is related to IT. We applied the random forest classifier algorithm on the data set to predict if the job posting is IT related or not. During the model training, we split the data using the ratio 80:20 to avoid overfitting. And as we all know, machine learning model works better with more data. After the use of a helper function with several algorithms, we chose the algorithm with the best accuracy. Working with the best performing algorithm, which was random forest classifier, we improved the accuracy by performing a parameter tuning using grid set CV. For our model evaluation, the model was evaluated using the accuracy metric used for classification process. The accuracy score was 1.0 on the training dataset and 0.9 on the test dataset. Here is a confusion matrix for the classification problem. We then validated the model to see features that influence the model. Developer, software, and JavaScript are good features to look out for if a job is IT related or not. The model was saved in a pickle file using the pickle library in Python called Streamlit. Streamlit is an open source Python framework that helps us create web apps for ML projects. The front end of the web app and deployment was done on Heroku. You can check out the app in this link here. So just here is a brief demo to show us how the web app works for its users. So you can select NLP, then you paste the job description and choose and analyze it. So it gives you suggested keywords that you can use to improve your application while applying. All right, so it can be based on our EDA conducted. It can be concluded that about 90% of the job posts were non-IT and top jobs were accountant, QA engineer. So this project analyzes the online job posting, taking Armenia job market as a case study. Many HR professionals require skilled people for their organization, but lose them because of ATS. Our module bridges this gap by helping non-English speaking applicants avoid errors while applying via the use of natural language processing to get useful keywords to aid the application and also help them predict if a job is IT related or not, because not everybody is interested in IT related jobs. Thank you so much, Amoye, for this opportunity. We appreciate it.
Okay, thank you so much for the presentation. Judges, you have questions or comments for them?
Yeah, like honestly, it was a very smooth PPT and I like the way you presented till the end. It's very good.
Thank you.
So, as you know, like this job posting is a very critical condition. It's very crucial. So, I lost you there where you tried to explain me where ATS is not working fine and your system will work fine. Can you explain me?
Sir, I didn't get that.
Like the ATS system, which is the
Okay,
traditional
okay.
system out
Yeah,
there.
we did not say. All right,
Yeah,
I get
how
you.
it fails, how
So
it
we
fails,
did.
and how your system helps.
Yeah, what we're just trying to say is that the ATS is used to filter keywords from people's application, and because of the bulk of application, they use this ATS to filter if these applications have their keywords. And we are now trying to, because even though keywords are being looked for on those people's applicants, it does not mean that people without the keywords are not qualified for that particular position. So our model is just there to help job applicants put in suggested keywords in their resumes, because you cannot just submit any resume to any job posting. You have to tailor your CV to look like what they are looking for in that specific job post. So that is what our model is trying to do. It's trying to help them get suggested keywords first, and also for people that are not interested in IT jobs, it's helping them get if this job posting is IT related or not. And okay, yeah, so like you can see from our data sets, there were more non-IT job counts. So it shows that people are recruiters in this data set were more interested in non-IT jobs. So our model is just helping us predict if this is an IT related job post or not, and also trying to suggest keywords that can be used to aid applications whereby they can get successful, just to ensure that they are not dropping good talent.
So basically, if a user comes to your platform, what they will do, they will just paste in the job description, and it will be giving the last the word cloud. Yeah, that's fine, but you just stick to one model. That's my concern.
What did you say?
In case of the prediction,
okay,
you only stick to one model. Yeah, that is my concern.
No.
You
Like I said,
no.
Sorry. Like I said, yeah, we used an helper function, and we used different models. We used k-nearest neighbors. We used linear regression. We used decision trees. So, but random forest classifier gave us the best model. That is why we now performed hyperparameter tuning with grid search to better improve the model.
Yeah, that's fine. But in case, suppose when you are using multiple models, you should put that matrix in front in the PPT. That would like more easily visible.
Okay, that's true. That's true. Oh, yeah. I'm very sorry about that.
Good work.
Yeah, thank you very much.
Okay, thank you very much for that presentation. Before the next team comes up, Team Apache, you'll be presenting last because you missed your time to present. So you'll be the last team to present. So moving on to the next team, Team Python. Our presenters are Sai Pavan, Emmanuel Precious, and Mame Ode.
All right. Good evening, everyone. Good afternoon, everyone. Panel. My name is Emmanuel Precious Joy. I am one of the presenters representing Team Python for the Premier Project presentation. And we're going to be talking about the mortality rate analysis in Germany. All right, next slide, please. Next slide. Okay, so we got our data source from, we got our data set from Kaggle, and our data set is on mortality by age and state in Germany. That's between the year 2016 to 2021. Next, please. All right, so our data processing was, the data set we got was in German. So we had to translate to English so that it was comprehensive for everybody. And then our data set was in an Excel file that had like so many tables, about I think 14 to be exact. And we had to extract the necessary table that we needed. And after that, we had to import it to our workspace and then format and get the necessary information to analyze our data. Next slide, please. All right, exploratory data analysis, we had to do, we answered the question of gender-based average death count from the year 2016 to 2022 in Germany. We also answered the question of the total amount of death across the different age groups within that year range, and also the aging population death counts from 2016 to 2022 in Germany. Next slide, please. Now I'm going to hand over to my partner to give us insight on the analysis that was carried out. Ode, over to you.
So from our analysis, we realized that for the first 3 years, there was a uniform increase of the death rates between males and females in Germany. But then from 2018 to 2019, there was a decrease. And this was as a result of Germany being able to finally complete their complex healthcare system. And then as at from 2019 to 2020, we realized there was an increase in the death toll, which is as a result of COVID. And then in 2021, it started to go, it was still going up. And as a result of the number of waves that they experienced in Germany. In 2021-22, we realized that the death rates started to decline because they started to recover from the fallout of COVID. In the next slide, we looked at the total death counts across different age groups. And we realized that for the age groups from 0 to 40, they had a lower death count as compared to the aged age group. And from that, we made the analysis that Germany had high standard of living, because when you have a high standard of living, your life expectancy, you have higher life expectancy. That's why we see that in the age groups, we have people living up to 95 and above. And in our last slide, we looked at the average daily death count in Germany for the aged population, and we defined the aged population to be 65 and above. And as expected, in 2016, from 2016 to 2018, there was an increase in the death count. And in 2019, we saw a dip because Germany was once again able to take care of their healthcare system. And in 2020 to 2021, that's when COVID hit and they had to go through all the waves of COVID. That's how come they had such a high increase in death counts. And then in 2021, 2022, as we use the aged population, we're still being affected by the fallout of COVID, and also due to their old age. That's why we see an increase in their death rates. So I give over to my colleague to give us the summary.
Analysis, we can see that we didn't have sufficient data to know the cause of death in the year 2016 to 2021 and some part of 2022. This is the reason why we just assumed that in the years that we had higher death rate, it was due to COVID, because COVID was ravaging the whole world. Okay, so, but we believe that if we had more data, like specific data, such as cause of death, fertility rate, mortality, infant mortality rate, we would be able to have predicted and recommended more solutions on the high aged death rate. Thank you very much.
Yeah, can you hear me?
Yes, we can.
Yeah, so thank you. Yeah. So I just have a few questions from your if you go back to your slide, the data wrangling and processing. Yeah, your data, yeah, the translation from German to English, like can you like just hint me on the process, like how you carried out?
All right, we used Google Translations. Yeah, we just copied. Most of the data was, it was basically the columns, the headers that were in German, and then the title of the worksheet in Excel. So what we did was just copy and paste, and then we got like literal translations of the data. So it just gave us like an idea of what they were trying to say. So we now use our common sense to like, okay, this is talking about like the week or the month or the year or the time frame of the mortality rate.
So, like, was that not a tedious work to copy and paste?
It was tedious, sir, because like I was telling them that we could have gone for another data set, but I think that was what we assigned at the beginning. Well, we had options to like change, but I don't think anybody was willing to change, so we just took it and we just ran with it.
Okay, and then your EDA, I don't know why. Yeah, the place you factored in the male and female death rates. So
Yeah.
I was really concerned because why are females dying from 2016 to 2018? The number of females dying is more than that of male, and then towards 2021, 2022, there's kind of decline. So was there a reason for that?
Well, we would have known if we had like a cause of death, but what we had in our worksheets were just dates, age range, week, month. Like we didn't have like courses and all of that. That's why I was saying that if we had like a specified data set or like more data, we would be able to know why these things were happening. We just happen to have just this limited data.
Yeah, so Precious, I wanted to ask like the certain question, like I wanted to ask like more like a likely question to that for slide 10. So there was a spike in death rates from, I think that was from 2019. I mean, for 2020, I mean that was basically COVID, but then I was sort of expecting a decline. But then you said the mortality rate and every other features were not factored in. Would have be able to identify why that is.
Well, between the year 2019, 2020, 2021, and 2022, I feel like it is COVID. Between the year 2021 and the 6-7 months of data that we had for the year 2022, I think it was still a relapse because a lot of countries in Europe were still battling COVID. Like it was still
expected or published statement which
I'm sorry? Oh, okay.
All NBA team for the 2015, 2016, and 2016 to 2017. Working on this data set, we deployed 5 approaches, which are problem definition, laboratory data analysis, picture engineering selection, model building, metavisual model deployment. Topic.
All right, thanks. Over to you, Emmanuel. Over to the next group, please.
Well, thank you very much for that presentation. Moving on to the next team to present, that will be Team Scikit-Learn. Team Scikit-Learn, their representatives are Ibrahim Kosoko, Ikiora Ekene, and Gloria Madife.
Hello. Hello,
Yeah, your voice is a little bit faint, not that audible.
Can you hear me now?
Yes, you can. You can start sharing your screen.
Okay.
Time starts now.
Okay. Can you see my screen?
Yes, you're good to go.
Okay. Thank you. Good evening, everyone. My name is Gloria Madife, and with me is
Kiara Kini.
We are from Team Scikit-Learn, and the topic of our presentation is gun violence. These are members of our team, and the problem statement we are working with is the rise in lack of profitable unemployment as a reason for the bane of gun violence. And the aim of our project is to review the trends between gun violence in the United States and unemployment. We conducted explanatory data analysis using Python, and then we cleaned the data set using and prepared it for visualization using Tableau. We got the data set from Cargo. It's a data set from 2013 to 2018. So I'll quickly rush to our dashboard. The gender distribution of gun violence from 2013 to 2018 shows that the prevalent gender that are involved in gun violence are male from 2013 to 2018. The age distribution of those mostly involved in gun violence are those in their 20s. That's this one you're seeing. So from the ratio in this pie chart, you can see that the ratio of those that are involved in gun violence mostly are those in their 20s, that are like about 40% of the total ratio of those involved in gun violence. We also give a state representation of those states that gun violence are mostly located. That's mostly in California, Texas, and all this. We had to get a supporting document to show that in these states, unemployment there's a high level of unemployment in these states. Like in California, for example, which has of about 5,562 cases, there's unemployment rate of about 8% rate of unemployment. This statistics was gotten from the Bureau of Labor Statistics. I'll give it to my teammate to continue from here. Thank you.
Okay, good afternoon once again. So after analysis was done, we went over to making predictions with data provided. The normal model was used to train the model with parameters PDQ, referring to the autoregressive parameter, difference parameter, and as well as the lag parameters. So after tests were conducted, tests like ADF, as the ADF to find out the differential parameter value of 1, and tests like autocorrelation and partial autocorrelation to find the remaining values P and Q. So after this model was built, we went on to evaluate the model, to test the model and training sets, the metric mean absolute error, and compared it to the base model. So the base model, which was obtained by using the mean values of the data, that's the number of people injured or killed, we had 27.29, and the other value, which is for the ARIMA model, was 9.8. That's just for the training set. Then went on to validate this using the test set. Test set gave an ME score of 11.98, as seen below, Then after we tested this, we went on to try our hands on making forecasts. The ARIMA model was built to forecast the future rate of victims likely to be affected by gun violence. As you can see, it's from 2018, that's March to April 13th, a 1 month gap here. So we can see that we have a recurring pattern here. And if you check those, it would see that the peak here, it happens on the weekends and at the trough here. It doesn't mean that there isn't lots of gun violence or cases on weekdays, but then it's not as much as the weekends. Next slide. Next slide.
You have 30 seconds more.
Okay.
Next slide.
Okay.
Observations. The analysis revealed that less than 5% of suspects were arrested. So this makes citizen resolve self-protection. From our recommendations, we can see that since gun violence in circulation and prevents number of victims also increases, this implies that in order to reduce the number of victims associated with gun violence, number of gun in circulation must be reduced significantly. Thank you very much. And changes are also stated here below. Thank you very much.
Okay, thank you for that presentation. Shiva, you have a question for them?
Yeah, I would just like to say that the Tableau dashboard was quite well explained. And I just have one question. Were you being the outputs you got from this entire analysis, were you being able to connect with the real world? Yeah, am I audible?
Yes.
So I was saying, the analysis that you got from this output, were you able to connect with the real world? Okay, that's fine.
So,
okay, thank you.
Hello? I'm not hearing.
Yeah, over to you, Christian.
Okay, thank you for that. Moving on to the next team, Team Steamborn. Your representatives are Daniel Crew and Ibrahim Ogubuyi. You can start sharing your screen now.
Yeah, can you hear me?
Yes, we can hear you now.
Okay, yeah. So good day, everyone. My name is Ibrahim Ogubi. So I'm representing the team Seaborn. So our problem statement is we actually want to predict weather condition for some certain city based on time. So using machine learning model. So so this is our data set. This is our project workflow. This is our project workflow. This is our data set description. Actually, data was gotten from Kaggle, so it consists of different states in United States, Canada, and Israel. But like due to time constraints, we're not able to like focus on the entire data set. So we just choose to focus on New York and a certain weather attribute, which is temperature. So this is the exploratory data analysis. Since it was gotten from Kaggle, so there wasn't much data processing and cleansing, but it had some null values, some missing values. So we made sure we filled it with forward and backward filling. And as well, the daytime object is in the form of a string. And we made sure we converted it to a daytime object in the hour of one frequency. So these are descriptive statistics. We find out that in New York, as in across 2012 to 2017, we found out that the minimum temperature was 250 and the maximum was 310. And the average temperature over the years in New York was 285. So this is the distribution of the temperature in New York over the years. We can see that it's a normal distribution curve which possesses a uniform seasonal change. So this insight is something that actually I feel like I learned as well for myself. In this insight, this trough here that I'm hovering my mouse on, it shows that what's it called? That in New York, it shows that February 2015 was like the third coldest month that ever happened in the history of New York. I mean, like it was like the coldest month that ever happened. And this place that I'm moving on the peak, it shows that like July 2013 was the hottest, period in the entire history of New York. So the model training, so we used what's it called, an autoregressive model to train our model, and we performed some set of hyperparameter tuning to select the best parameter. So after we selected the best parameter, then we built our model, our final model using a technique called walk-forward validation, which basically means that you take historical data and then try to, train the model every time, like, so we get to the last piece of data sets. So summary for our data sets, like I've said earlier, like we saw some insights that, communicated to us that February was like the coldest and July was the hottest in the history of New York. So some of the challenges that we faced was like due to like time constraint, we're not able to like, work on more advanced model. Because one of the things that we saw was that the walk forward validation technique that we use, if it was to be like big data, it won't be kind of efficient. But like due to time constraint, we are now able to like explore like some deep learning models that like this word forecaster, like Google, something like that, they make use of. So that is basically all about it. Thank you very much.
That was a fast one. Okay. Basi, you have a question for them?
Yeah, the model, what model did you use and what exactly did you factor in? So I know this is a time series problem. Did you use Arima, Sarima, or the
Yes. We make use of R model, AR model, just basically AR model.
Why?
Yes, like the use of
weather prediction is seasonal. I guess it's seasonal. So if you just use the autoregressive model, so why didn't you factor in the season and other things? I mean, just tell me the reason why you use the autoregressive model.
Yeah, like we started, basically.
Can you go to take your slide to the model?
Yeah.
Go ahead.
So like I say, like the normals for machine learning is we try from like basic and then see how, like we try basic machine learning models, then we advance to like advanced one. So we tried the AR model, but when we tried it and we saw that the accuracy score was was okay. So we're not able to because of time constraint, we're not able to say we want to check other different kind of model.
All right, thanks. That's all for me.
Thank you very much for that. Moving on to the next group, that's Team Selenium. The representatives are Abdulhamid and Vishal.
So yeah, is my screen visible?
Yes, you can.
Yeah, thank you.
Yes. The time starts now.
Good afternoon, everyone. This is the Selenium team presenting our HDSC Premier project. The topic today is foreign exchange rates forecast. Next slide, please, Vishal. Our presenting to you is me, Abdulhamid Ibrahim, and Vishal Grad. Next slide, please. We'll be taking you through the details of our project, which are the objectives, our approach to achieving this objective, exploratory data analysis, building the machine learning model, and the conclusion. Next slide. So fluctuation of foreign exchange rates currencies has another effect on investors, traders, and the economy. It disrupts investment, it discourages savings, and it affects the general public as a whole. Our objective for this project is to produce a directional foreign exchange forecast that are able to give profitable investment strategies. Next slide, please. So to achieve our objective, we conducted a time series analysis and built 3D machine learning models to predict the future values of foreign exchange currencies and got the best performing model in terms of the least error using performance evaluation metrics. We developed, back to the previous slide, please. We developed a linear regression model as our baseline model. We developed a Riemann model and a loop process model. Please, next slide. So the workflow for this project was divided into 5 parts, which are the data sorting, the data wrangling, exploratory data analysis, machine learning model building, and the model evaluation. Next slide, please. The data set was obtained from Cargo. It contains the time series column and 23 different currencies with their exchange rate in dollar for a period between 2000 and 2019. Please, next slide. We discovered that there were 5,217 observations and 24 columns. We dropped irrelevant columns and not values. We converted all our columns to the correct data types. Next slide. So we decided to predict the UK pound exchange rate with dollar. So we check its distribution using the density plot as shown on the left part of the screen. Please over it. So the density plot shows a distribution that is close to the normal distribution. So we plotted the time series plot too, and on the time series plot, we discovered that there was no seasonality, and we discovered a trend, and we observed that there is no seasonality in the time series plot. Vishal, over to you.
Yeah, thank you, Ibrahim. So we actually saw from the line plot that the data is non-stationary. So we decided to do a ADF test, which is also called as augmented Dickey-Fuller test. This is a test to identify whether a time series is stationary or not. So we can clearly see from the top left box that the p-value which is obtained is 0.66, which is very high. as compared to the accepted p-value of 0.05. So we can clearly see that we are unable to reject the null hypothesis, and we can say that the time series is non-stationary. From the ACF and the PACF plots, we can clearly see that there is high correlation between the time series, our time series with the lag values at different time periods. So in order to remove the non-stationarity in our data set, we decided to difference the data set once in order to remove the trend part in this. We actually saw that there was no seasonality in the data set and only trend. So we decided to do one differencing in order to remove that non-stationarity. And then we again ran the ADF test, and we can clearly see from the top left box that the p-value is almost close to 0, which shows us that the time series has become now stationary. We decided to run 3 graphs. So the first model, we decided to run 3 models, and the first one was our linear regression model, which was our baseline model. The second model which we ran was our ARIMA model. Since we choose to run ARIMA model since our data set had only trend part and there was no seasonality. And the last model which we decided to run was FB profit model. Looking at the different evaluation metrics, we can clearly see that ARIMA model was the best model as it scored the least in terms of error on all the different metrics which we used. We used mean absolute percentage error, the mean absolute error, mean squared error, and the root mean squared error. So in summary, we can say that for time series forecasting purposes, as long as there is no seasonality and there is only trend in the data set, we can clearly see that the ARIMA model was the best performing model and had the least error in forecasting, or we can conversely say that it has the highest accuracy. Thank you.
Thank you very much for that presentation. Shivam, you have a question from there?
Yeah, I just have a few questions. Like, we have talked about foreign exchange for only US dollar, or like it is US dollar or UK pound?
Yeah, hi Shivam. So yeah, we had actually foreign exchange rates for a total of 22 countries in the data set. So each of them was obviously a time series data set. So we decided to just go for one particular column and for one particular country in order to make our analysis easy. So since this is a time series analysis and we do not need any predictor variables for this, so we decided to portray this. Yes, for UK. So and the same can be replicated for other countries as well.
So my question is, how did you deal with the missing values in time series?
So we actually had for some of the few rows we had.
What methods you took?
Correct. So for most of the data set we had values, but for some of the rows in between the data set we had ND values, which we assume that it stands for no data. So since there is not a lot of change in the foreign exchange rates in a few days, so we decided to take an average of the last 3 days and populate the data set according to that.
So now the question is, why only the average?
So we took average because when we saw the data set, we saw that the values which were given from the past values, I mean the values which we had at a time period T were highly dependent on the lag values of the same time period. So we decided to go for the average values as they were giving us good results.
Okay. So just like suppose I'm an investor who basically invest in this foreign exchange. So what value you are going to give me from this project?
So we can actually, so there are 2 things. So one of the thing is that we were able to make use of a very limited number of models. So obviously we can go for some of the advanced models in the deep learning using LSTM or something like that, and we can make predictions using that, use that model to deploy it into the production, and from that we can actually get what is the trend that is going to be in the near future, and the investor can basically make right choices as and when they should invest into the market, or maybe try to figure out about the different macroeconomic factors of the country which might be dependent on the foreign exchange rates.
Okay. Yeah, thank you. Good work.
Thank you, Shivam. Thank you all.
Okay, thank you very much for that presentation. Up next, Team Source Code, Adeyemo and Solomon. You have the floor now.
Yeah, good day, everyone. My name is Solomon Ogundeji from Source Code. My colleague and I will be presenting the classification and prediction of dementia Before I go ahead, I would like to say a big thank you to all my amazing team members for the attitude towards bringing the project to completion. Dementia is the seventh leading cause of death and a major cause of disability among older people. It is often misunderstood and ultimately leads to stigmatization and barriers to diagnosis and care. The existing method for detecting dementia is through manual diagnosis, where doctors check medical history and conduct physical examinations for symptoms. They also ask someone close to the patient about visible symptoms. At Source Code, we are implementing an artificial intelligence diagnostic system that provides an automated diagnosis without a specialist. It provides accurate results, which would help break the barriers to diagnosis and care. The data set we used in training the model was collected from Kaggle, and it consists of a longitudinal collection of 150 patients between the age range of 60 to 96. Each patient was scanned at least twice for a total of 373 imaging sessions. 72 of the patients were categorized as non-demented and 64 as demented. 14 patients were categorized as converted, that is, those that were originally diagnosed as non-demented and subsequently diagnosed as demented. The features we used include education level, sex, clinical dementia ratio, estimated total intracranial volume, mini mental state examination score, age, and normal whole brain volume. I will now hand it over to my colleague to continue from here.
Thank you very much. Can you hear me?
Yes, we can.
Yes. Okay, my name is Abdulmalik Adeyemo from Source Code. We performed the following preparation on data sets. We dropped the default columns such as the MRI ID and the patient ID and the AND ID and the AND column. Then we changed the categorical column to numerical columns, after which we filled in missing values. We performed feature to output correlation to help select the features that affect our output the most and drop those that were not. We removed the necessary outliers, and finally, we normalized the features to help our model train better and faster. Through visualization on the clean data set, we identified that 57% of our patients were non-demented, 32% were demented, and 11% were converted. Also, more females were non-demented than male, more male were demented than females, and more females were converted. The model was experimented. The model we experimented on include the support vector machine model, the logistic regression model, the random forest model, and extreme gradient boosting model. The best, which is the random forest, was selected based on the accuracy report, which includes precision, recall, and F1 score metric. On the test set, the model correctly categorized all non-demented and demented category. It miscategorized one converted category as demented and 5 converted category as non-demented. In summary, we were able to determine the type of dementia by looking at the clinical dementia ratio, which ranges between 0 to 2. Also, given that the converted category was gotten after the fact, it is necessary to have just demented and non-demented category for successful real-time application. Finally, we also observed a better performance without the converted column. Thank you for listening, and we will now go ahead and show our deployed model. Please let me know if you can see my screen and the deployed model.
Yes, you can. You have 40 seconds.
Okay, so, all right, thank you. So what we have here on the left-hand side, we have the user input where you can select different parameters, which was used to train the model. And then once you're done selecting that, then you can go ahead and click on the predict button, which is going to predict if the patient has dementia or does not. And in this case, we have the prediction to be non-demented. And of course, we have the confidence level, which is also the probability of prediction, which in this case, we have 99% confidence level that, okay, yes, this patient was actually predicted to be non-demented. Thank you very much. That will be all.
Okay, thank you for that. Thank you for that. Basti, you have a question for them? Comments?
Yeah, thank you. Did you check? I'm sure there are existing solutions. Like, did you check for existing solutions to this? Because this is a very critical problem.
Yes. Thank you very much. Yes, we did check existing solutions, especially those that were published in journals and conferences. Yes, and for our solution, one of them had a sensitivity of 57%, precision of 68%, which our own is actually performing better than theirs. So we did check them, and then we're able to benchmark our results with theirs, which in our case was performing very well. Thank you.
Yeah, that's all. Thanks.
Okay. Thank you very much for that. Moving on to the next team SQL. Chinyere and Bertram, are you here? Team SQL, Chinyere and Bertram and David Kwenev. Okay. The time starts now. We can't hear you. Unmute you.
Good day, everyone. Can you hear me?
Yes, we can now.
Okay. Good day, everyone. My name is Bertram Mukonkwo. On behalf of Team SQL, I'll be anchoring this presentation titled Gold Rates Prediction. Prior to the beginning of this presentation, we tried to partition our agendas into 6, starting from the problem statement down to the conclusion. For the problem statement, we'll try to accurately predict the future adjusted closing price of gold across the given period of time in the future, as well meeting certain objectives. These objectives will include making sure our model does not take too long to return prediction, that is latency concern. We would also want to maximize the coefficient of determination, that is the R square, and as well minimize the root mean squared error. Based on existing solutions, we made reference to various sources similar to ours, and we realized that authors of these sources made use of models like artificial neural network and autoregressive moving average, AMA. Our approach for this, we started by processing this data. For processing this data, we checked for missing values and made sure we clean duplicate features. We also went on with the EDA, that's the exploratory data analysis. By doing this, we got insight regarding the causes for change in the asset price, which is gold. We also carried on with modeling. By modeling, we made use of different regression models where we evaluated using the RMSE, that's the root mean squared error, and the R square, and we carried on with deployment. For the data set description, our data was collected from Kaggle with features of about 1,718 rows and 81 columns. I would like to make mention that this data didn't meet all quality tests, and we made corrections for this. For the EDA, we raised about 6 questions. These 6 questions will include trying to understand the trend of gold price over time and investigating the autocorrelation of the time series. Now, still on EDA, you can see some graphs here. The first graph is trying to understand the trend of gold price over time, while the second graph, because of the volatility of gold prices, we tried to streamline this into the last 3 years in order to understand the recent trend of gold prices, in order to draw insight from this. Looking at this, we also try to visualize different statistical values like the rolling mean and the standard deviation, which is the first plot there. The second plot you're seeing here are components of the time series. That is the trend, seasonality, and the residuals. Moving on to the feature selection phase, we use variance inflation factor. We try to use this to compare for each feature, and in the end, we ended up selecting 8 features. This is a summary of all the modeling styles we used, like linear regression down to ARMA, lasso regression. Looking here, the highlighted models are those that perform poorly. Looking at this, we picked linear regression as our best fit. Applying linear regression on the cross-section validation data, it gave us the first plot result, and we also carried out linear regression on the test data, which is the results you have on the second plot. Looking at this, you can see linear regression performed relatively well too. Concluding this, at the EDA phase, EDA made us understand these different models which we applied, like the moving window average we performed. That did quite well, but the moving window average did quite well, but it didn't take into consideration other features. And for the ARIMA performed poorly and didn't meet latency concern. So we ended up settling with linear regression because it was fast and produced accurate results. I'll hand over to my colleague, Mr. David, to take on with the recommendations. Mr. David.
Yeah, thank you very much for that wonderful presentation. Now, considering the fact that we have changing time and seasons, and by extension, changing market conditions, we'd like to recommend that this model be retrained with most recent data at regular time intervals, say once in every 2 months, or once in every 2 weeks, or once in every 1 month, for it to continue performing optimally. Here is a demonstration of the model in production. A user enters the most recent values of the 8 features in order and clicks submit. The model then returns the prediction almost instantly in accordance with the low latency constraint of the business problem. Thank you.
Okay, thank you very much for that wonderful presentation. Shivam, you have questions for them?
Yeah, just one question, like, how did you guys manage the latency issue for the model?
Come again?
How did you manage the latency issue?
To manage the latency issue, we considered those algorithms that are fast, mostly in prediction, like the linear regression, XG. Please go back to the model inside. We considered linear regression, Riemann, and decision tree. All these models are fast. And again, to make it faster, we tried to drop off from 81 features that we had. We tried to select the most relevant ones. We try to decrease it down to 8. In that way, it reduces the training time and the prediction time as well. Thank you.
Okay, yeah, that's fine. Thank you.
Okay, thank you very much for that. Moving on to the next team TensorFlow. Udo and Fidel.
Hello.
Yes.
Good evening, please. Can you unmute Fidel so he can present?
He's already on mute. Can unmute himself.
Fidel, please, can you present your screen?
Okay. Time has already started.
Good evening, everybody. We are Emekudo and Fidel Imasuen representing Team TensorFlow. The title of our presentation is the prediction of the nitrogen oxide NOx pollutant levels at different stations in Madrid using machine learning. The next slide shows the active members of Team TensorFlow. Our problem statement is the prediction of the NOx pollutant levels at different stations in Madrid. Next slide. Our aim is to build a machine learning time series forecasting model to predict the future NOx level. Our approach. Our aim and objective is to build a machine learning time series forecasting model to predict the future NOx level. Now, the approach we used was to use the k-nearest neighbor machine learning algorithm. This was chosen because it gave us a better performance compared to other methods. Next slide. Dataset description. The dataset we used was obtained from Kaggle. It was made up of 19 files divided into 2. The first 18 showed the pollution measurements of the different pollutants from 2001 to 2018. And the second showed the properties of the different stations, such as longitude, latitude, elevation levels. Next slide. All right, so this is a snippet from the first part of the data set showing the pollutants from 2001 to 2018. Next slide. And this one now shows the second part of the data set consisting of the names, the IDs, the longitude, and the latitudes of the different stations. Next slide, please. Okay, for our workflow, we had the data cleaning, data exploration, data visualization, feature engineering, model training, and model deployments. Next slide. For our data cleaning, the steps we took were as follows. The combined data set was grouped per station, with each station extracted and cleaned separately. For the missing values that were less than 1% of the total entries were replaced by 0. and missing values greater than 1% of the total entries, but less than 70% were replaced by the median. And then missing values greater than 70% of the total entries were dropped from the data sets. At this point, I want to hand over to Fidel as he continues.
So for the data, in the data exploration phase, we only consider stations that contain carbon monoxide and nitrogen oxide. This was done because it's generally believed that sources of nitrogen oxide also tends to be sources of carbon monoxide. Hence, it's important to see the relationship between these the two pollutants. From the diagram, we can see how nitrogen oxides vary for different stations over time. We can also see that the pattern it remains the same for the same stations for the pollutants carbon monoxide, and this pattern is repeated for all the other stations as seen on the slides. Another way to investigate the relationship between stations is to use the correlation matrix. And for the correlation matrix for station Barrow, the pillar as shown, can be seen that the highest correlation coefficient corresponds with that of nitrogen oxide, thereby validating our analysis or our hypothesis that NOx and CO actually have a strong correlation. And it's the same for all the other stations as well. In this next slide, we see we created different elevation ranges above sea level, and we analyzed, we just showed the top 3 occurring pollutants based on elevation level, so as pollutants tend to change. However, the nitric oxide pollutants remain the same. It can be seen as shown. Then for feature engineering, we reduce the granularity of our data set from hourly interval to a monthly interval. The machine learning library used to create the machine learning time series forecasting model is called SKTime, and the following steps were followed in creating the forecasting model. First of all, several machine learning instances were created. The models created were linear regression, random model, random forest, and k-nearest neighbor. The data set was split in such a way that
you have less than 15 seconds.
Okay, so this is the model, absolute percentage error of each as shown. I can be seen the random forest and k-nearest neighbor deployment, and we deployed our app on Gradio on Hugging Face using Gradio. In summary, we can say that the k-nearest neighbor was what we used, and that the ability to forecast pollution levels can help us to take appropriate measures to reduce pollution. A further area of research is to use deep learning algorithms for forecasting, but we didn't actually do that well.
Sorry, time's up. Time's up for you. Basi, you have a question for them?
Yeah, quick question. You use the k-nearest neighbor algorithm for your model. So my question is, can you give me tell me just a bit explanation of how k-nearest neighbor works, and why do you think it was the best model for your use case? Did you get my question?
Yes, I get your question. So k-nearest neighbor is what we classify as a weak learner. So when we were creating our machine learning models, we started from very simple models like linear regression and graduated to more complex models like random forest and k-nearest neighbor. So with the library that we use, which is called SKTime. SKTime enables us to actually use machine learning models to actually predict time series data, right? So the way k-nearest neighbor works, it's more or less, you can use it for both classification and regression, and it does tries to place similar values in different areas or different classes. So personally, when we tried the 3 models, k-nearest neighbor was what gave the highest performance when it came to the metrics that we tracked. So that's why we went with it.
All right, thank you.
Okay, thank you very much for that. Moving on to the next team, Team Tiano. Your presenter is Kevin Wawero. I don't know if I pronounce that correctly. Okay.
Hello, how are you?
Yeah, we can hear you.
Could you please let Stuti
You
present?
You can.
My other teammate is Stuti. She needs to present. To bring up the chart, the slides.
The time has started.
Okay, thank you and welcome to our presentation. My name is Kevin Waweru, and okay, so my other teammate is Stuti. So our project mainly was about e-finance and e-finance research. The whole goal of our work was to, if we could go through the introduction, was basically, so far the growth of technology has changed how we do things, and more people have access to the internet, and more people have access to internet-enabled devices. So what our group wanted to see mainly was to understand how research has been ongoing over the last couple of years, decades I mean, and to see what work people have been studying in relation to e-finance. Would you get the next slide, please? So the whole idea was to understand, as many people say, research informs practice. So if we could see the trends in studied topics, if we could see the trends in areas researchers are finding problematic, the buzzwords, the keywords, the themes, we could possibly help the same researchers to find understudied areas and also to find more papers that can help them locate the information that they require. So we needed to see how the changes have been and how impactful the research has been. Next slide, please. Considering we are mainly data analysts, we decided to work with, of course, the Python programming language. And our goal was just to understand trends and patterns, as I have explained. We saw our data will
The analysis process of our data set then starts by checking the integrity of the already prepared and thoroughly cleaned data. The clean data set was analyzed to show the number of citations and disparate frequently used keywords. The trend of publications over the years was also analyzed and represented on a line graph. Here is illustrated before you a line graph showcasing the trend in the number of documents released over the years on e-finances yearly from the inception. It is evident from the plotted graph that e-finances document releases peaked at around 2010. We discovered many published documents, significant articles, and conference papers taking a higher spot. Most of the documents cited by the authors were of the e-finance industry. Also, the document by Craner and Wong in 2010 was the most popular article around the time and could have possibly contributed to that year's tremendous effect. Now depicted before you is a word cloud showing author keywords, which was designed to show the essential words which have greater prominence in the documents that make up the data set, clearly indicating the tremendous usage of words like commerce, financial services, economics, and more. Diving deep into the analysis, we discovered that some other factors have significantly impacted e-finance. Factors such as banking services, commerce, health, and government have contributed to the impact and growth over the years, as shown by the citation keywords of the authors. Therefore, we can predict that financial services will continue to be more impactful and keep growing due to the advent of more sophisticated technologies in the present day. Afterward, a keyword extraction was done from the data to give the correct information. Hence, keywords from index columns were extracted and ranked based on how frequently they occur in the data set. And therefore, in this regard,
seconds more.
A bar graph was depicted visualizing the acquired results showing that finance and electronic commerce and e-finance were ranked the highest. The language with which the documents were released were represented using a horizontal bar graph. English contributed to about 95% of the documents in the dataset, with German, Chinese, and Polish representations following it in the same order. Therefore, I would like to conclude by mentioning that our goal was to understand the keywords, buzzwords, and theme that were present in the e-commerce publications and research works. Our total enabled us to see the top 10 studied and top 10 covered keywords, phrases, and research terms. These are the areas that require further interest, and we recommend that the financial researchers and students intending to cover these areas use our findings to identify potentially viable research questions. Thank you.
Thank you very much for that. Shivam, you have questions, comments?
Yeah, I just have one question, like, what do you understand by e-finance? Am I audible?
Yes, you are
Yes,
audible.
you're audible. Please repeat your question.
Yeah, I was saying, like, what do you understand by e-finance, and what was the output of your entire analysis?
So it's basically the provision of financial services and markets using electronic communication and computation. And I believe that our project solution was meant to highlight the journey of various researchers as it influenced not just finance, but governance and commerce, as evidence is given in our dissected data set.
Okay, that's fine. Thank you.
Okay, thank you very much for that presentation. We'll be moving on to Team Apache. They missed the first time to present. Are they here now? Success Chile and Bolarinwa for Team Apache. Ngokwe Success Chile and Bolarinwa for Team Apache. The time starts now.
Hello. Good evening. Good evening. My name is Professor Chile. Please can you hear me?
Yes, we can hear you clearly.
Okay. My name is Professor Chile, representing Apache team alongside with Aishat Bolarewa. And the rest of the names here are the members of the group, active members of the group. Next slide, please. We worked on a data set extracted from Cargo, and we extracted our problem statement, which is to predict all NBA teams for the 2015 and 2016, to also predict whether a player will make it to the Hall of Fame. Next slide. Our approach to this data. We had about 5 approaches, which are problem definition, exploratory data analysis, feature engineering and selection, model building, and evaluation. The fifth one is model deployment. The topic of this data set is men's professional basketball stars of various teams and coaches in men's pro basketball leagues. We had about 11 data sets, and we used about 5 data sets to produce a data set that is fit for prediction. The topic, again, I have to repeat it. The topic of this data set are men's professional basketball startup players and coaches in men's pro basketball leagues in 1937 to 2012. Total number of data sets extracted was 11, but we utilized 5 data sets to build our model for prediction. In data wrangling, we replaced null values, thereby creating a fixed data set. Going to visualization, you will have an appropriate insight of what our data set entails. The first, Aisha, please, can you share the slide? Can you move? Hello, can you hear me?
We can hear you, but your slides are not moving. Your teammates, she having issues moving her
Okay.
slides.
Please, can I continue?
Yes, you can.
Going to visualization, you will have an appropriate insight of what our data set entails. The first bar plot, I noticed you could see that California and New York City has the highest number of birthdays compared to Georgia and the rest. Likewise, USA, Yugoslavia recorded the highest number of birth countries compared to Poland and Turkey, respectively. Please move to the next slide, Aisha.
Can you see my screen?
You will see yes, you can see, yes, I can see your screen. So move to the next slide. On the next slide, you can see total number of losses per year. You will see that 2010 recorded very minimal number of losses or higher chances of winning compared to 1963. Next slide, Aisha. The next slide reviews the total number of wins per year. 1995, the players recorded amazing victory compared to the other years. Moving to the next slide of coaches with respective losses, you can see that the coach with the ID Shedor 01 had fewer losses compared to Bianca 01. Next slide shows coach with the ID Jasper 01 had the highest recorded victory compared to the rest. Aisha, please, can you take over from here? Hello, Aisha.
I have 40 seconds left.
I'm so sorry. I think my colleague is having network issues.
Okay, no problem. You can continue. $20 left.
So from our model, you will see two different machine learning methods were employed in the prediction logistic regression, which gave a 80% and 73.3 accuracy in the 2015 to 2016 and 2016 to 2017 NBA team prediction. So from the prediction, predicted NBA team for 2015 to 2016, you can see that we use logistic regression model, and you find out that
in summary, for the logistic regression model, 11 out of 15 predicted teams were correct. And for the 2016-17, 12 out of 15 predicted team members were correct. And for the sub-vector model, 9 out of 15 predicted players were correct. And that's for the 2015-16 prediction. And for the 2016-17 model, 12 out of 15 predictions were correct. In conclusion, machine learning algorithms can be used to predict a game. In sports, prediction is a very common occurrence, and there are various factors that can affect the efficacy of a prediction model. Combination of two or more models gives a high.
Sorry, your time is up. Time is up. I added extra minute for you. Basti, you have any comments for them?
Yeah, so I just have one question.
Okay.
So can you just walk me through your entire problem statement and what you were trying to predict? Am I audible?
Yes, you are. Sources and Aisha, can you hear you clearly? Ask the question.
I can hear you, please. Can you come again?
Yeah, I was saying, can you just walk me through your problem statement and what was you trying to predict?
Our problem statement was to predict the players that will participate in the NBA basketball league for 2015-2016 and 2016-2017. That was our problem statement.
And so we also try to predict whether a player will make it to the Hall of Fame.
Okay. So what was the output of your analysis and how would you pitch to me?
We used logistic regression machine learning model, and structured vector machine learning model to predict the players that will participate.
Okay. So can you tell me what were the key performance indicators that you found out? Okay, then yeah, no worries. Thank you.
Hey, thank you very much for that presentation. And I'll say we'll come to the end of today's session. Wow, that was breathtaking. Different teams and their presentations, their methodologies, their modeling, their analysis, and all that. Goes to show that machine learning, data science is a very key input in whatever you're trying to do to make life better or move yourself forward. Okay, this time I'll call Eyene to give on the closing remarks.
Hello, everyone. Thank you very much. Thank you, Christian, for having that wonderful session. And thank you to our interns for the very awesome presentations, condensing all that work you've done over the past weeks in your various groups to a presentation that lasts for only 5 minutes. Must not have been easy, but we are super proud that you did it, and we're super proud of the growth that you must have incurred in the course of doing this project. I want to say a big thank you to Shivam and Basil, our awesome judges from Harmony AI Labs. Any final words for our interns and perhaps recommendations for future project presentations? Basil and Shivam.
Yeah, I just have few words for all the interns out there. First of all, like you all have did a very fabulous job. I would like to congratulate you for that. Just being from this entire experience that I have, I would just like to say that modeling is not always about giving input and getting output. You have to connect it to the domain and you have to connect it to the real world, like the output is concerned to the real world or not. So these are some of the things that you have to always keep in mind. Yeah, wish you a very best of luck. Thank you.
Thank you very much, Shivam. Basil, do you have any final words or recommendations for our interns?
Yeah, so nice work, everyone. I mean, it takes a lot of effort to put all this together, and I must commend all of you for working as a group, putting everything all together. But then there are some things that needs to be pointed out so that in subsequent projects you need to factor in those things. The first is the deck, the slides. I think it's like about 2 or 3 groups that I love their slides, the consistency, the color, like the font consistency, the color. So it's not a good idea, trying to cluster your slide, from each slide to the next, you're seeing like different multiple colors or multicolors. So you need to find a way to be consistent with your color, your text color, and the background, as well as the fonts, the choice of fonts you're trying to use. That's that. And then for the project, it's very important that you maintain some approach. Or I mean, the approach to different, like there are different approaches to like different projects, but then you need to take note of the fact that I mean, if you're doing presentation of a project, you need to give us a well-detailed problem statement. Like we want to know the problem you're trying to solve, and then we want to know your data description, the data you're trying to use to solve that problem. And then you need to also do some exploratory data analysis and visualizations. You need to like show us, like explain to us how the data is, the analysis and the insights you got from the data. And then you need to use those insights to answer some research questions if needed. And then go ahead and tell us about how you were able to process your data, do your data cleaning, and whatnot. And then the model and algorithm selection. Sometimes when you're selecting model, you don't actually need to start going for it. You can start from like the very small models, linear regression, logistics regression, as the case applies. And then another thing you need to put into perspective is adopting techniques and approaches from existing open source state-of-the-art models or open source projects. So it's not like I mean, most of these solutions like that there have been problems that have been solved. So you need to somehow not trying to reinvent the wheel, but then you can look at projects that have been done and then try to improve on that. So another thing is for you to discuss the results. The results you got, like, were they able to answer the problems earlier stated? Were they able to provide a solution to the problems earlier stated? And then discussions and then conclusions, and yeah, basically that. So nice work to everyone, and then yeah, kudos. Thanks.
Thank you very much, Basil. Thank you once again, our dear interns and the various teams, for a job well done. Further information regarding your results will be available on the Slack channel. And to all our presenters and to all the team members being available to chair your various team on, I want to say a big thank you to you for a successful session. With that, we've come to the end of this presentation. So